Hello, 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 hello. Hello, my dear students. Am I audible? Hello. Hello, Nila. Nila, hi, Nila. Fan, hi, Nila. Hi, Rukmani. Yes, I think. Yeah, it is audible. Guys. Ojal. Okay. Hello, Jahi. Yes, now I can see everyone. Jahi, Ojal, Nila, Darshini, Thiru, Shanmita. Actually 11 o'clock time change பண்ணல அதனாலடா 11 o'clock தான் class சொல்லியிருந்தது time இது வரைக்கும் change பண்ணல so that is the reason so quickly like the session so quickly smash the like button da voice super clear okay Shiva hello Shiva where is Hepsi akka Hema akka and Takshan யாடா ஆக்சுவலி அது டைம் ஆக்சுவலி 11 தான் ஓகே மார்னிங் 11க்கு தான் இருந்தது பட் டைம் சேஞ்ச் ஆயிடுச்சு ஓகே ஸோ டைம் சேஞ்ச் ஆயிடுச்சு அதனால எஸ் நிலா நிலா ஸோ எப்படி கால் பண்ண முடியும்டா நான் இப்போ போய் கால் பண்ணி எப்போ தக்ஷன் வரும் ஜஸ்ட் செகண்ட் இங்கே எனக்கு சாட் ரொம்ப ஸ்மாலாக பார்க்குது ஓகே நீங்க தானே சிவா தக்ஷன் கூட கால் பண்ணி ஜிமீட் பண்ணி கிளாஸ் எல்லாம் எடுக்கிறது கிளாஸ் எல்லாம் லைக் கம்பைன் ஸ்டடீஸ் எல்லாம் நடக்குதுல்ல உங்ககிட்ட தானே நீங்க கால் பண்ணி கூப்பிடுங்க தக்ஷனை தக்ஷன் ஜிமீட் வாட்சிங் யா I have seen that story ஜிமீட்ல நீங்க கிளாஸ் பார்க்குறதும் ஓகே தக்ஷன் ஆக்சுவலி தக்ஷன் நேற்று சென்ட் பண்ணியிருந்தது ஓகே ஓகே ஸோ கைஸ் நாம் இன்னைக்கு பார்க்க போகிறது 2 சாப்டர்ஸ் தான் redox reaction and yes redox reaction and D block elements. So in the ரெண்டு சாப்டர்ல இருந்து you will get like maximum 3 question to 4 question okay from this chapter you will get they will ask maybe 3 to 4 question okay so and this is very important chapter ada edinalana I will tell you it is very easy to learn okay so easier yes Hari good morning so easier in the chapter learn பண்ணலாம் okay because it's very easy chapter okay so உங்களுக்கு 4 questions okay not 4 mark 4 question இங்க இருந்து lock பண்ணலாம் that means you will get 16 marks okay so 4 question means easier you can lock 16 marks from this chapter okay in the chapter la irundha almost okay 16 mark definitely question varum you can lock 16 marks from this session okay so I think you all are ready guys are you ready set so guys tell me how is your preparation going da question practice alla eppadi nadakudhu so preparation eppadi pogudhu tell me quickly in the chat box ready so tell me how is your preparation going ma'am super ah pogudhu illa na ma'am avlo super illa fire ah pogudhu it's good so far ma'am yeah it's so nice touch wood அப்படியே இருக்கட்டும் preparation வேற லெவல்ல போகுது okay nice going well ma'am yes ma'am going somewhat but productivity is low yeah why da productivity low so guys the content alle so content refresh பண்ணி question practice பண்ணனும் அவ்வளவுதான் Okay, so content உங்களுக்கு ப்ராப்பரா தெரியும். அந்த content refresh பண்ணிட்டு just you can do questions. Yes, Siva saying. Hemapriya is also here. Yes, Hema, how are you? How is your health? இப்போ எங்க இருக்கு? இப்போ எப்படி இருக்கு? Hema, so tell me, how is your health ada? Question practice is low, ma'am. Okay, so don't worry da. So I will tell you one thing. Okay, so நமக்கு actually 21st க்கு தான் exam. Okay, so in the complete month actually May month இப்போ இன்ன 19 ஆயிடுச்சு. Okay, so இன்னைக்கு 19 தான். 92 மேல 30 இருக்குல்ல. So 30 daysல நீங்க ப்ராப்பரா content revise பண்ணுங்க. Okay, so content revise பண்ணிட்டு you can do parallelly questions also. Okay, in the 10 days la you should finish all your content. Okay, content complete in the 10 days la finish பண்ணனும். Yes, 31 days left total. Yes, so in the content in the month la complete content finish பண்ணிட்டு next month la we can start GOC lesson PDF ஆகல மேம். எடா PDF just download to our telegram channel. Telegram la we are sharing session PDF. Okay, காலையில முருகுக்கு போயிட்டேன், இப்போதான் வீட்டில் வந்துருக்கேன் மேம். 2 days after went to. ஓகே, எஸ் எஸ் went. ஓகே, ஐ கேன் அண்டர்ஸ்டாண்டடா. ஸோ ஹெல்த்தும் பாரு, ஹெல்த் இஸ் ஆல்சோ வெரி இம்பார்ட்டன்ட். ஓகே, ஹெல்த் இருந்தால் மட்டும்தான் உனக்கு ப்ராப்பராக நீட்டுக்கு படித்து நீட் எழுத முடியும். ஓகே, ஸோ ஹெல்த் இஸ் வெரி இம்பார்ட்டன்ட். எஸ் டா நவ்யா, குட் மார்னிங், டேக் கேர் அக்கா. எஸ், டேக் கேர்டா. ஸோ ஹலோ தக்ஷன், வந்துட்டேன் மேம், நான் பார்க்கலடா உன்னை. வந்துட்டேன். ஓகேடா. ஸோ எஸ், ஸோ கைஸ் இந்த 10 days, ஓகே, இந்த 10 days நீங்கள் கம்ப்ளீட்டாக உங்களோட கண்டென்ட் ஃபினிஷ் பண்ணணும். ஸோ சப்போஸ் உங்களுக்கு மேபி நியூ டாபிக்ஸ் படிக்கணும் அப்படியெல்லாம் இருந்தால் இந்த 10 daysல ஃபினிஷ் பண்ணிக்கோங்க. அண்ட் பாக்கி இருக்கிற 20 days, ஓகே, ஐம் நாட் கன்சிடரிங் 21 days, ஐம் கன்சிடரிங் 20 days. உங்களுக்கு ஆக்சுவலி 21st எக்ஸாம் தான். ஸோ பாக்கி வர்ற உங்களோட 20 daysல you should focus completely questions. Okay, complete questions focus பண்ணணும். You should do maximum question. ஸோ அதுதான் நாமளும் பண்ண போகிறேன். ஸோ இது வரைக்கும் உங்களுக்கு கிளியர்னு நினைக்கிறேன். ஏதாச்சும் டவுட் இருக்காடா? இது வரைக்கும் கிளியர் இல்லை. ஸோ ஃபர்ஸ்ட் you should finish your content, then you can start doing questions. Okay, first finish the content, then you can start doing questions. Ma'am, did you? இல்லடா, நோ கோல்டு, நத்திங். சவுண்ட் டிஃப்ரெண்டா இருக்கா? ஐயோ, தெரியல, எனக்கே தெரியல, கோல்டு இல்லைன்னு நினைக்கிறேன். ஸோ எஸ் சேம் பட் மேனேஜ். எஸ், ஸோ இந்த மாதிரி ஃபாலோ பண்ணால் உங்களுக்கு கொஞ்சம் கூட ஈஸியாக இருக்கும். ஓகேடா? ஸோ எஸ். அண்ட் கைஸ், நீங்கள் எல்லாரும் கேட்குறது மேம் நோட் எப்படி கிடைக்கும். ஸோ யூ கேன் சி our டெலிகிராம் சேனல் லிங்க். ஓகே, ஸோ லிங்க் கீழே இருக்குது, டிஸ்கிரிப்ஷன் பாக்ஸில் இருக்குது. ஸோ இப்போவே போய் ஜாயின் பண்ணிக்கோங்க டெலிகிராம் சேனலில். ஸோ டெலிகிராம் சேனலில் இருந்து உங்களுக்கு நோட் கிடைக்கும். இல்லைனா ஓகே, டெலிகிராம் சேனலில் இல்லைனா ஜஸ்ட் ஜாயின் பண்ணிக்கோங்க. we will give you extra notes and everything. ஓகே, டெலிகிராம் சேனலில். அண்ட் உங்களுக்கு பார்த்தா தெரியும் Re-NEET 2026ஓட, ஓகே, Re-NEET 2026ஓட ஒரு ஸ்பெஷல் கிராஷ் கோர்ஸ் we started. Okay, so complete free crash course. Okay, from there you will get more than 45 full length mock test. Okay, so yes, here you can see, yeah, so you can see description box la. So join free Re-NEET 2026 crash course. Guys, it is completely free. Okay, இது completely free தான். ஸோ உங்களுக்கு இங்கேருந்து ஆல்மோஸ்ட் 45, ஓகே, நமக்கு ஆக்சுவலி 30 days தான் இருக்குது. ஆனாலும் we are giving 45 free mock test. ஓகே, full length mock test. ஓகே, ஸோ ப்ராப்பராக நீங்கள் எப்படி நீங்கள் எக்ஸாமுக்கு எழுதுதோ அது மாதிரி அந்த அட்மாஸ்ஃபியரில் இருந்து அந்த 45 mock டெஸ்ட்டும் எழுதுனா you will get confidence definitely. ஓகே, ஸோ உங்களோட Re-NEET கொஞ்சம் கூட ஈஸி ஆகும். ஓகே, நாட் கொஞ்சம் கூட, ரொம்ப ஈஸி ஆகும். ஓகே, ஸோ எஸ், நெக்ஸ்ட், ஓகே, அங்கே இருக்கிற ஃபீச்சர்ஸ் தான். ஸோ யூ கேன் ஆக்சஸ் library. Okay, உங்களுக்கு அங்க இருந்து library access பண்ணலாம். So libraryல more than 100 books உங்களுக்கு இருக்கு. So அந்த reference book உங்களுக்கு access பண்ணலாம். So reference bookல question practice books இருக்கு and different reference books இருக்கு, content ஓட books இருக்கு. Okay, so அங்க இருந்து உங்களுக்கு practice பண்ணலாம். And next is you can join to a Telegram channel. So Telegram channel la we will update இன்னைக்கு class இருக்கு, இந்த டைம்ல class இருக்குன்னு ப்ராப்பரா we will update. So உங்களுக்கு அங்க இருந்து அந்த class பார்க்கலாம். I mean classல உங்களுக்கு அங்க இருந்து கிளாஸோட நோட் இல்லனா லைக் ஏதாச்சும் நோட்டிஃபிகேஷன் எல்லாம் இருந்தா அங்க we will upload. Okay, and we will give you extra note. டெலிகிராமில் எக்ஸ்ட்ரா நோட்டும் கிடைக்கும். ஸோ எல்லாரும் மேம் ஹேண்ட் ரிட்டன் நோட் வேணும், ஹேண்ட் ரிட்டன் நோட் வேணும்னு கேட்டது. ஸோ கைஸ் ஹியர் யூ வில் கெட் ஹேண்ட் ரிட்டன் நோட் இன் டெலிகிராம் ஆல்சோ. ஓகே, அண்ட் இங்கே ரீநீட் கிராஷ் கோர்ஸ். ஓகே, கிராஷ் கோர்ஸில் ஸோ உங்களுக்கு அங்கே இருந்தும் நோட் என்ன டவுன்லோட் பண்ணலாம். ஓகே, உங்களுக்கு அங்கே இருந்தும் நோட் download பண்ணலாம். And my dear students, one more thing. So yes, offline NEET repeater program. Okay, so we already launched offline NEET repeater program. So it's starting from 18th May. 18th May ke already batch start ஆயிருக்கு. So you will get 90% up to 90% உங்களுக்கு scholarship கிடைக்கும். Okay, up to 90% scholarship உங்களுக்கு அங்க இருந்து offline என்ன சென்டர்ல இருந்து. ஓகே, ஆஃப்லைன் நீட் ப்ரோக்ராம்ல இருந்து அப் டு 90% என்ன ஸ்காலர்ஷிப் கிடைக்கும். இப்போவே உங்களோட சீட் புக் பண்ணிக்கோங்க. எஸ், அண்ட் இதுதான் ஆஃப்லைன் சென்டர்ஸ், தமிழ்நாடுல இருக்கிற ஆஃப்லைன் சென்டர்ஸ் இதுதான். ஸோ உங்களோட நியரஸ்ட் அண்ட் கைஸ் JEE admission இருக்கு, NEET admission இருக்கு, 8th to 10th ஃபவுண்டேஷன் கிளாஸஸும் we are providing. And you can see இப்போவே ஏதாச்சும் என்கொயரி ஏதாச்சும் இருந்தால் you can call to this number for enquiry. And yes guys, few seats மட்டும்தான் இருக்கு. ஓகே, பிகாஸ் பேட்ச் ஆல்ரெடி ஸ்டார்ட் பண்ணி இருக்கு. ஓகே, ஸ்டார்ட் பண்ண போகிறேன். ஸோ ஃபியூ சீட்ஸ் தான் இருக்கு. ஸோ இப்போவே போய் உங்களோட சீட் கன்ஃபார்ம் பண்ணிக்கோங்க, லாக் பண்ணிக்கோங்க. ஓகே, ஸோ எஸ், ஸோ we can start our session. I think you all are ready guys, we can start. So before starting the session I just want to ask some questions. Yes guys, what is redox reaction? What is redox reaction? Yeah, what is redox reaction? Yeah, what is redox reaction? What is redox reaction? You get redox reaction. What is redox reaction? என்னடா redox reaction னு சொன்னா 2 rupees then pay. எடா what எடா 0 fees எடா. Yes, actually 0 fees தான் இருக்கு. If I click it has no டா, it is 0 rupees தான் இருக்கு. ஸோ உங்களுக்கு இங்கே பார்த்தா தெரியும். ஓகே, யார் கிளிக் பண்ணி 2 rupees கேட்டு இருக்குடா. ஸோ எஸ், ஹியர் யூ கேன் சி ஜாயின் ஃப்ரீ ரீட். எஸ், ஹியர் யூ கேன் சி பை நவ்னு பார்க்கும்போது ஐயோ மேம் பை நவ்வா. யா, ஹியர் யூ கேன் சி 0 rupees யூ கேன் பை. ஓகே, ஸோ கிவ் யுவர் ஃபோன் நம்பர் அண்ட் டீட்டெயில்ஸ் எல்லாமே கொடுக்கும்போது யூ கேன் ஜாயின். ஓகே, ஸோ திஸ் வே. ஓகே, ஐ ஹோப் இட்ஸ் கிளியர். யாரு 2 rupees சொன்னது? நவ்யாவா? யாரடா, யாருக்கு 2 rupees? தர்ஷினி நோடா, 2 rupees ஒன்றும் இல்லை, 0 தான். Take the screenshot and send it to me. Okay, I will check. Okay, okay. So yes, I can see answers. Hi Navyashri. Yes, Navyashri. Good morning guys, good morning guys. He is giving good morning to everyone other than me. No ma'am, Darshini. Okay, Darshini. So guys, what is a redox reaction means? So redox reaction means oxidation and reduction simultaneously occurring reactions are redox reaction. Oxidation plus reduction. Okay, So oxidation plus reduction occurs simultaneously. That is actually redox reaction. Okay da? Oxidation, reduction, simultaneous nadakira reactions are actually redox reaction. So here you can see redox reaction. So reaction in which oxidation and reduction occur simultaneously. So guys, my next question is, what is oxidation? What is reduction? Okay. So what is oxidation and what is reduction? So I am writing here oxidation, and here I am writing reduction. So tell me, what is oxidation, what is reduction? Good morning, good morning, good morning, Padma, Padmanabha. Okay. Gain of oxygen. Okay. Oxidation means addition of oxygen. So I am writing plus O. Okay. And minus H, elimination of hydrogen. Okay. So reduction is just opposite of oxidation. So here, after a long time, I am seeing a person here. Oh my God. Lots of internet issues. Why? Where are you? Chumma you are saying alle. Okay. So here you can see minus O, elimination of oxygen and addition of hydrogen. Okay. Ma'am, explain slow. Okay. Yeah. So oxidation means addition of oxygen, removal of hydrogen. Reduction means addition of hydrogen, removal of oxygen. Also we can say that another oxidation means what? Any other definition for oxidation? Is there any other definition for? I know you are saying chumma, not chumma saying na. You are liar. You are a liar. You are lying. I know. I can see in your Instagram. Okay. Okay. So plus, okay. And here I will show you, it is loss of electron, or we can say oxidation is losing of electron and reduction of gaining of electron. Okay. Oxidation na enada? It is losing of electron. Reduction means gaining of electron. And one more point, oxidation means oxidation number increases. Reduction means oxidation number decreases. Okay. So here you can see all the definitions. Oxidation is losing of electron, removal of hydrogen, addition of oxygen. Oxidation number increases. Reduction means gaining of electron, addition of hydrogen, removal of oxygen. Oxidation number decreases. Okay. This is the definition of oxidation and reduction. So guys, first we are discussing about oxidation number or oxidation state. Okay, this is very important. So, charge present on individual atom after all its bonds are broken. So, based on electronegativity. So, there is 2 points. Okay. So, we will normally say oxidation number. Okay. We can say that oxidation number means charge present on individual atom after all bonds are broken. So, ella bonds break pannadukku appuram enna charge kadakidho adudha oxidation number. I hope it's clear. So, after bond breaking, okay, bond breaking appuram enna, for example, when you consider H2O, okay, this is, so inga hydrogen enna bond break pannirukku, okay, hydrogen oxygen bond break aidichu. So bond break agumbodhu, so hydrogen will get positive charge, oxygen will get negative charge. Okay, so when you consider this bond, so inga bond break agumbodhu hydrogen will get positive charge, again oxygen will get negative charge. So what is the oxidation number of oxygen? 1 minus 2 minus. So oxidation number of oxygen is actually minus 2. I hope it's clear. I hope it's clear. This is actually oxidation number or oxidation state. So we can check. Yeah, here you can see same. Okay, when you consider HF, okay, when you consider HF, so what will happen? We know that here also, if this bond breaks, hydrogen will get positive charge and fluorine get negative charge. Okay, so H positive and F negative. Okay, this will be the charge. So what is the oxidation number of hydrogen? It is +1. Oxidation number of fluorine, that is -1. Okay, I hope it's clear. Then we can do some more examples. Okay, in case of non-metals we can do. Okay, so when you consider non-metals like in a HF, HCl, okay, HF, HF, HCl. Okay, so what will happen if, okay, hydrogen bond irukku, okay, hydrogen mela bond irukku. So yes, this bond will break and hydrogen will get positive charge and fluorine will get negative charge, and here also this bond will break, hydrogen will get positive charge, fluorine get negative charge. Okay, fluorine get negative charge. So idu first we are considering hydrogen dhan consider panna pola, hydrogen. Okay, hydrogen தான் consider பண்ண போறேன். This is non-metal hydrogen. So when you consider metal மேல hydrogen வந்தா metal. So bonded, hydrogen is bonded with metal. When you consider NaH, okay, when you consider NaH, what is the oxidation number of Na and H here? Tell me what is the oxidation number of Na and hydrogen here? Sodium and hydrogen, tell me quickly. NaH, oxidation number, tell me. Come on. It's okay, Nila. Rukmani. Padmanabh. Ojal. What is plus 1? What is minus 1? Who is minus 1? Who is plus 1? Na plus H minus. Yes. So Na plus and H minus. When you consider KH, okay, when you consider KH, what is the oxidation number of K and H? What is the oxidation number of K and H? Yes, here also it is plus and it is minus. When you consider CaOH, so not Ca, CaH2. 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 What is the oxidation number of calcium and what is the oxidation number of hydrogen? What is the oxidation number of calcium and what is the oxidation number of hydrogen? Tell me quickly. 0, 0. You are saying 0. Now we are sure. Calcium. Fatima is saying calcium is plus 2 and hydrogen is minus 1. Bunny. Yes, Bunny. Plus 2 minus 1. Okay. So yes, the calcium is actually here plus 2 and hydrogen is actually for 2 hydrogen, actually for 1 hydrogen it is minus 1. If you consider 2 hydrogen it is minus 2. Okay. So hydrogen, okay, hydrogen non-metal mele bond irundiruchina. So here you can see hydrogen and fluorine. Fluorine is a non-metal and hydrogen and chlorine. Chlorine is a non-metal. So here you can see the oxidation number of hydrogen is plus 1. Okay, if hydrogen is bonded with a non-metal, then the oxidation number of hydrogen is always plus 1. Okay, most of the time it is plus 1 only. If hydrogen is bonded with a metal, you can see the oxidation number of hydrogen is actually minus 1. Okay, the oxidation number of hydrogen is actually minus 1. So my next question is, hydrogen is bonded with hydrogen. Okay, hydrogen is bonded with hydrogen. So tell me, what if hydrogen bonds break means what is the oxidation number of hydrogen? So if this bond breaks means what is the oxidation number of hydrogen? If the hydrogen bond breaks, so what is the oxidation number of hydrogen? Zero, ma'am. Bunny is saying 0. Plus 1. Fatima is asking plus 1. Rukmani, correct, ma'am. Yeah. So, Bunny, do you know how I identify you? So, I am just checking the chat, okay? So, I have seen that orange color dress students with this emoji, okay? So, I have seen. So, then I realized, oh, Bunny is came. Okay, so if this bond break means, I will tell you here, hydrogen is sharing one electron, this hydrogen is also sharing one electron. You can see homolytic cleavage here, homolytic cleavage, okay, homolytic cleavage here. Then what will happen? This electron will go with this hydrogen and this electron will go with this hydrogen. So oxidation number will become 0, okay. Oxidation number or oxidation state will become 0 in homolytic cleavage. Okay, I hope it's clear. Do you have any doubt? It is 0, guys. It is not +1, -1. It is 0 because you can see it is actually homolytic cleavage. Okay, it is homolytic cleavage. I hope it's clear. Yeah, I can understand. Yeah. So this is your what? Trademark. Your trademark is this one. Yeah, that girl. Clear, ma'am? Crystal clear. Okay. Then guys, so we are checking of fluorine. Okay. So when we are checking fluorine, so next is actually for fluorine. Okay. So fluorine, so yes, here you can see H, FH, FCl. Yeah. So if this bond breaks means fluorine, chlorine, fluorine, hydrogen and fluorine any other element, okay, any other element. So what will be the oxidation number of fluorine? What is the oxidation number of fluorine? F also there. So tell me, you can write the oxidation number of fluorine. 1, 2, 3. Okay, Takshin, perfecto. Yes, perfecto, Takshin. Ma'am, in Re-NEET bio, not going. Yes, the bio, I think within 2 days bio class irukku. Okay, here I can see. Yes, if this bond break means we already discussed, it's -1 and it is +1. If this, we know that fluorine is most electronegative element, okay. So it is a high electronegativity showing element. So what will happen? Here also it will show -1. Here also it will show +1. Chlorine will show +1 here, okay. Because we know that fluorine is most electronegative element, okay. So here also fluorine show -1 and chlorine show +1. So guys, this one, when you consider fluorine, okay, when you consider fluorine, then what will happen? When you consider fluorine, then what will happen? What is the oxidation number of fluorine? Fluorine in fluorine or fluorine in F2. What is the oxidation number of fluorine in F2? -2. -2. Their periodic table F is like lion, electronegative. Yeah, true. Bunny Maharaj. Come on. -2. No, guys. It is actually 0. So, same element, okay. Same element in a bond means, okay, it's homo molecule. Okay, it's a homo molecule. So what will happen, Ada? So, here, if this bond break means this electron go with this fluorine, this electron go with this fluorine. So, the oxidation number will become 0. Okay, oxidation number will become 0. Okay. Okay, so oxidation number is actually 0 here. So, I think it's clear. So, when you consider, yes, I can write. When you consider fluorine, it is always, okay, always -1. Okay, it is always -1. When you consider fluorine, it is always -1. Okay, so then we can consider another molecule, that is OF2. Okay, oxygen. Next we are going to consider about oxygen, that is OF2. So this is OF2. OF2. So tell me, what is the oxidation number of oxygen and fluorine? What is the oxidation number of oxygen and what is the oxidation number of fluorine? Come on, da. Come on, Rukmani. I can't understand, ma'am. Okay, you can't understand last one. Okay. So after this, I will tell you again. Okay, same concept only. Here we can. Okay, I can't not understand now. Don't worry. Oj, what is your name? I forget your name. Okay. So no, don't worry. Which element is more electronegative, da? Which element is more electronegative? Which element is more electronegative? Oxygen or fluorine? Oxygen or fluorine? Rukmani, Ojal, yes. Ojal, which element is more electronegative? Yes, I can see. Yes, Ojal, tell me. I think others are saying correct answer. So, Ojal, oxygen or fluorine? Oxygen or fluorine? Oxygen. No, fluorine is more electronegative. Okay, fluorine is, when you consider any of the element in periodic table, fluorine is the most electronegative element in the periodic table. Okay, fluorine is the most electronegative in the periodic table. So here we know that oxygen is sharing one electron, fluorine is also sharing one electron. Okay, oxygen is sharing one electron, fluorine is also sharing one electron. So what will happen? Fluorine is most electronegative element. So fluorine will attract the 2 electrons. Okay, fluorine will attract these 2 electrons and fluorine will get negative charge. Okay, so oxygen will get positive charge. I hope it's clear. So when you consider this bond, so here also oxygen is sharing one electron, fluorine is sharing one electron. Here also fluorine is more electronegative. So it will attract the shared pair of electron. Okay, it will pull toward itself. Okay, so then what will happen, Ada? So here also fluorine will get negative charge, oxygen will get positive charge. Okay, I hope it's clear. Then what is the oxidation number of fluorine here? It is -1. So what is the oxidation number of fluorine here? It is -1. What is the oxidation number of oxygen here? Here you can see 2 positives are there. So that means it is +2. Okay, that means it is +2. I hope it's clear. I hope it's clear. I hope it's clear. Then we are discussing about O2F2. Okay, O2F2. This is very important molecule. Okay, guys, this is very important molecules. So OOFF. So now you can write the oxidation number of oxygen and fluorine. Come on. Come on, come on. I hope it's clear, Rukmani. D. What D? No. No D, no options. +1, -1. Okay. Who is +1? Who is -1? Ma'am, 2 electrons are gaining. No, gaining. No, fluorine, then it's -2, ma'am. No, actually this is 2 different atoms, Ada. So listen, da, fluorine is not -2. Okay, fluorine is not -2. Here you can see this is different atom. Okay, different fluorine. Okay, ma. Bunny, man, 2 electron are gaining fluorine, then it's -2. No, it is actually, yes, this is another fluorine. This is another fluorine. Okay, it is different fluorine atoms. Okay. This is different fluorine atoms. Okay. So come on, tell me the answer for this question. So here I will tell you. So guys, here I am going to break the bond. So I am going to break this bond. So we know that when you consider oxygen and fluorine, fluorine is more electronegative. So -1. It is +1. So if you consider this oxygen and fluorine, I am going to break this bond. So here also oxygen is +1, fluorine is -1. If I am breaking this bond, okay, if I am breaking this bond, then what will happen? Same atom, okay, oxygen, oxygen, same atom. So nothing will form. Oxidation number will become 0. If I break this bond, means this oxidation number will become 0. So guys, oxidation number of this oxygen is actually -1. Oxidation number of this oxygen is actually -1, this fluorine -1, and this fluorine -1. I hope it's clear. Clear, Aleda? Yes. Not 0, but yes, if you are breaking same atom, okay, if you are breaking same atom or a bond means you will get, that is actually homoleptic cleavage, okay, that is actually homoleptic cleavage. I hope it's clear. Then we are moving to peroxide, okay, I hope it's clear. Okay, yes, cool. Then we are moving to peroxide. So peroxide, what is peroxide, Ada? That is H2O2. So what is peroxide? It's a book-like structure, okay. So tell me, what is the oxidation number of oxygen in peroxide? So they will ask this type of question once again, ma'am. Okay, I will tell you again. So this question allada, this question alle. Ma'am, explain once. Okay. So here, okay. So da, what will happen? So here fluorine oxygen bond will break, okay. We are going to calculate the oxidation state or this, yes ma'am, okay. Yes, oxidation number. So if this fluorine and oxygen bond break means, yes, fluorine is most electronegative element. Obviously fluorine will take that 1 electron, okay, 1 electron of oxygen. So it will get -1, okay, it will get the oxidation number -1, it will become -1. So when you consider this oxygen and fluorine, okay, when you consider this oxygen and fluorine, same, if this bond break means we know that fluorine is more electronegative. So what will happen? Fluorine will attract that 1 electron. So here fluorine will get -1, okay, fluorine will get -1, and when you consider oxygen, oxygen will get +1, okay, oxygen will get +1. If 1 electron is donating means, yes, obviously the donating atom will get positive charge and accepting atom will get negative charge, okay. So I hope it's clear. If same atom, when you consider oxygen bond is breaking, okay, oxygen bond is breaking means what will happen, Nada? So if this bond break means, so you will get oxidation number of oxygen is 0, this also 0. So why? Because here you can see this oxygen is sharing 1 electron and this oxygen is sharing 1 electron, okay. So we know that it's double bond, so I am writing just single bond, okay. So yes, what will happen? So if this bond breaks means you can see homolytic cleavage, okay, homolytic cleavage. So homolytic cleavage means, so this oxygen will get 1 electron and equal distribution of electron, okay. Homolytic cleavage means equal distribution of electron. So here you can see oxidation number is 0, 0, 0. So here also same. If this bond break means here no electron, equal electron distribution. So the oxidation number is +1, +1, -1, -1. I hope it's clear. Guys, do you have any doubt? Peroxide is used to clean, yes, that is a bubble. Come, yeah, correct. So, yes, here you can write peroxide. So, what is the oxidation number of peroxides? No doubt, ma'am, clear. So, peroxide is very important, okay, da? Peroxide. Okay. Okay, da, Fatima. So if you have any doubt, you can ask, okay, I don't have any problem to repeat. So if you have any doubt, just ask, I will repeat 100 times, okay, no issue. Hydrogen peroxide. Okay, da. Yeah, I will tell you oxidation number, how to find oxidation number. Fano. Okay, can I start? So here you can see same, what will happen, the oxidation number of oxygen is actually, when you consider hydrogen and oxygen, Which element is more electronegative? Obviously, oxygen is more electronegative. So, oxygen is actually -1 and hydrogen is +1. Okay, I hope it's clear. So, when you consider this bond, okay, same here, hydrogen is +1 and oxygen is -1. Okay, oxygen is -1, hydrogen is +1. Okay. So, if I am going to break oxygen-oxygen bond, what will happen? Oxygen-oxygen bond means nothing will happen. Okay, nothing will happen. I hope it's clear. I hope it's clear. Okay. So, what is the oxidation number of hydrogen here? It is +1. Oxidation number of oxygen, it is -1. Oxidation number of this oxygen, it is also -1. Oxidation number of hydrogen, it is +1. I hope it's clear. So, when you consider peroxide, okay, when you consider peroxide is always, okay, peroxide la oxygen or oxidation state or oxidation number is always -1. Okay. That's why I will attend your lecture. No. Array. Okay. So I hope it's clear. So when you consider this is peroxide, okay. When you consider superoxide, okay. When you consider superoxide, so when you consider superoxide or oxidation number, okay, superoxide or oxidation number, okay, O2 minus, okay, O2 minus, okay, it's always O2 minus, okay, O2 that minus, okay, charge on amalgam, and then one more point, okay, so charge on amalgam, so we know that different type of amalgams are there, mercury amalgam, okay, mercury and sodium amalgam, okay, different type of amalgams are there. So when you consider, if they asked charge on amalgam means it is also 0, okay, amalgathoda charge is also 0, okay. I hope it's clear. I hope it's clear. This is very, very important, okay. Then we are moving to next question. Oxidation number of, calculate the oxidation number of, or I will write here, okay, H2SO4. You can calculate the oxidation number of sulfur, okay. How we will calculate oxidation number of sulfur? Calculate oxidation number of sulfur. Calculate oxidation. Metal mixture, amalgam. Metal amalgam, yes, metal amalgam. For example, we know that sodium, mercury amalgam, and there is more amalgams, okay, metal mixture amalgam. Math lab. It's variable, ma'am. It is variable. You should calculate the oxidation number of sulfur from H2SO4. How we will calculate it? So I will tell you how to calculate. Okay, so here you can see hydrogen is always +1. Okay, and oxygen is always, okay, most of the time oxygen will shows what? -2. Okay, always. Okay, most of the time oxidation number of oxygen is -2. So how we will calculate oxidation number of sulfur? So here I am taking the oxidation number of sulfur is actually X. Okay, so how many hydrogen is there? 2 hydrogen is there. So +1 into 2 plus sulfur or oxidation number we don't know. So I am taking it as X plus oxygen 4 into -2 equal to 0. So you can calculate the X value. So what will be the X value? So 2 plus X plus 4 into -8 equal to 0. So here it is X is equal to 8 minus 2. Yes, you will get X is equal to 6. Yeah guys, X is equal to 6. plus 6. So the oxidation number of sulfur is actually 6. I hope it's clear. I hope it's clear. Then I will give you another question. You can calculate the oxidation number of phosphorus. Calculate the oxidation number of phosphorus. Clear? Calculate the oxidation number of phosphorus. Kukka 6 money. Zaina 5 plus 5, Fatima plus 5. Abhinesh, Oja. Zaina saying plus 6. Okay, anyway, I will calculate, okay. H3, so we know that hydrogen is actually my plus 1 and oxygen is actually minus 2 and hydrogen is 3, hydrogen is there. 3 into plus 1 plus, we don't know, we want to calculate the oxidation number of phosphorus, so I am taking it as X, and next is we know that how many oxygen is there, 4 oxygen is there, so for 1 oxygen oxidation number is actually minus 2, it is equal to 0. So next, so 3 plus X plus minus 8. Yes, equal to 0. So you will get plus 5. Here plus 6 is another. So yes, you will get X is equal to, because X is equal to 8 minus 3. Okay, 8 minus 3. So you will get a plus 5. Okay, you will get plus 5. So I will give you another molecule, that is NO2 minus. NO2 minus. Calculate NO2 minus. What is the oxidation number of nitrogen in NO2 minus? Exceptional cases we will discuss right now. Okay, exceptional cases we will discuss right now. ஒரு பட்டர்ஃப்ளை ஸ்ட்ரக்சர் எல்லாமே கிளாஸ்ல சொல்லியிருந்தது. ஸோ அந்த சேம் பட்டர்ஃப்ளை ஸ்ட்ரக்சர் உங்களுக்கு எக்ஸாமுக்கு வந்திருக்கு. சேம் பட்டர்ஃப்ளை ஸ்ட்ரக்சர். Plus 3. Okay, let me check. So yes, we know that oxidation is actually minus 2. Okay, minus 2, and oxygen is minus 2, and we don't know nitrogen. Nitrogen I am considering X plus, how many oxygen is there? 2 oxygen is there. For minus 2 equal to minus 1, because here you can see charge is there, so minus 1. So X is equal to no, X plus minus 4 is equal to minus 1. So I am writing X is equal to 4 minus 1, you will get 3. Yeah, correct answer is 3. Yes, yes. You changed your shirt color. Yeah, I hope it's clear. Then we can move to exceptions. Okay, exceptions. So I will give you an exception. Yeah, you can calculate. Oh no, CN6 not charged. CN 6 times. Okay. You can calculate iron. Okay, this is iron oxidation number you should calculate. Can you tell me why it is plus 3? Can you tell me why it is plus 3? Can you tell me why it is plus 3? Yes, I can see lots of 3. Can you tell me why it is plus 3? Hi, Padmanabh. CN is neutral, very good. Then, yes, guys, correct answer. So, we know that cyanide is actually neutral ligand, okay? It is a ligand, it's a complex compound or coordination compound. So, it is a, here we know that cyanide, okay? Cyanide is actually neutral, it is neutral ligand. So, oxidation number is 0. So, here we know that for potassium, it is plus 1. So, we know that 3 potassium is there. So, it is plus 3. So, it's a neutral molecule, okay? It's completely neutral molecule. Then iron is actually plus 3. Not plus 3. It is, no. It is actually minus 3. Okay, guys? It is actually minus 3. Let me check 1 second. So, it's not... No, cyanide is minus 1 only. Let me check. Okay, 3 plus. Yeah, this is the answer, Ada. This is the answer. Ada, cyanide is actually minus 1, okay? Cyanide is actually minus 1. So, here you will get this answer, okay? So, for potassium, it is plus 1. So, we know that 3 potassium is there. So, 3 potassium. So, plus 1 into 3 plus X. We don't know the oxidation number of iron. Plus minus 1 into 6, you will get 0. So, 3 plus X plus minus 6 is equal to 0. X is equal to yes. I hope it's clear. You went to college? Okay. Then guys, I will give you another. There is 2 type of, I just want to add. Okay, when you consider coordinate bond, okay. So, coordinate bond consider pannumbodhu, there are 2 type of bonds. Okay, guys, listen carefully. Okay. So, what is actually coordinate bond means? So, I think it's clear. So, here you can see. Okay. Here you can see hydrogen, nitrogen, and this one is a coordinate bond. Okay, guys, this one is a coordinate bond. What is coordinate bond? Coordinate bond is also called dative bond. Okay, Coordinate bond is also called dative bond. So here nitrogen is giving electron to carbon. Okay, nitrogen is giving, not completely, okay, it's not sharing, it's not mutual sharing, it's not completely giving, nothing, okay, but here nitrogen is giving one set of electron, one pair of electron to carbon. That type of bond is actually dative bond. Okay, that type of bond is actually dative bond. So here you can see, when you hydrogen, what is the oxidation number of hydrogen and nitrogen? So we can break this bond. So we know that hydrogen is positive 1 and nitrogen is minus 1. I hope it's clear. So here we can see nitrogen, not triple bond, one dative bond is there, one pi bond is there, one sigma bond is there. Okay. So here this two bond will break. Okay. We can't break dative bond. Okay. We can't break dative bond. Okay, so dative bond means it is, we are not considering, okay, we are ignoring that dative bond. Listen carefully. Why? Because here the donor atom is actually nitrogen. So when you consider nitrogen and carbon, the electronegativity is more in nitrogen. Okay, the electronegativity is more in nitrogen than carbon. Okay, so electronegativity is more in donor atom. Okay, nitrogen is a donor atom. So here we can ignore the coordinate bond. I hope it's clear. We can ignore the coordinate bond when electronegativity is more in donor atom. I hope it's clear. If you have any doubt, you can ask. Okay, if you have any doubt, you can ask. Otherwise, I will continue. I hope it's clear. If you have any doubt, you can ask. Listening. Clear. Oja. So, dative bond. Clear. What is dative bond now? Okay. So, I will tell you dative bond again. Dative bond is actually coordinate bond. Okay. Coordination compound, you can see coordinate bond. That is actually dative bond. So, dative bond means here nitrogen only giving electron to carbon. There is no sharing, nothing. Okay. There is no mutual share. So, nitrogen is giving electron to carbon. Okay. Nitrogen is giving electron to carbon. That is the thing. So, here you can see this is actually dative bond. So, here the donor atom is actually nitrogen. Okay. Nitrogen is the donor atom and the electronegativity of donor atom is more than acceptor atom. Who is the acceptor atom? Carbon is the acceptor atom. Okay. So, carbon is the acceptor atom. Nitrogen is the donor atom. So, the electronegativity of donor atom is more. Then we can ignore the dative bond or coordinate bond. I hope it's clear. Clear, Ada? Oja? Clear. Clear, ma'am. The bunny, don't make funny. Bunny funny. Okay. So here you can see. So we can ignore this dative bond. Okay. Why? Because the electronegativity of donor atom is more. So we can ignore this dative bond. We can consider this bond. Okay. Pi and sigma. So what will happen? We can break this pi and sigma. So here I am breaking only pi and sigma. So what will happen? So we know that nitrogen is more electronegative. Okay. Nitrogen is more electronegative. Then nitrogen order oxidation number, now it is -2. And what is the oxidation number of carbon? It is +2. I hope it's clear. Do you have any doubt? So guys, what is the oxidation number of total oxidation number of nitrogen? Here you can see -2 and guys, here you can see -1. So total oxidation number of nitrogen is -3. Okay. So, total oxidation number of nitrogen is actually -3. I hope it's clear. Takshin, come and laugh. Otherwise, no answer. No reply. Nothing. Alle Dakshin? Alle Dakshin? It's clear. Okay. So guys, then we are moving to next type of coordinate bond, that is case 2. Here the donor atom, okay, the electronegativity of acceptor atom is more. Okay, the electronegativity of acceptor atom is more. Then we can consider acceptor and donor atom. Okay, so listen carefully. Then we are not ignoring anything. Okay, then we are not ignoring the dative bond. Okay. Oh, Shiva, really? Shiva, really? Ada, I want to see you all in the chat box. Then only I can understand. Note taking. So, Takshin, after that you should share the note, okay? I will check. You're taking note or not. Okay, so nice. So, very good actually. Ada, no, I am seeing your chat also. Your chat of Panita listening. Okay, that's so nice. Okay, don't worry. So here you can see case 2. Okay. So what is case 2, Ada? So here we know, here you can see that this is actually NO2. Okay, this is actually NO2. So here you can see nitrogen double bond O. Okay. So if this double bond break means what will happen? So nitrogen or a charge will become, we know that oxygen is more electronegative, then what will happen? Oxygen will attract that 2 electron. So the oxidation number of oxidation state of oxygen will become +2. If 2, because 2, okay, double bond is there, okay, double bond, 2 bonds are there. So it's breaking. So the oxidation number is 2. Okay, I hope it's clear. So here you can see the oxidation number of nitrogen I am writing here 2. Okay, oxidation number of nitrogen I am writing here 2. So guys, here donor atom and acceptor atom. So who is donor atom? Nitrogen is the donor atom. And who is the acceptor? Oxygen is the acceptor. So oxygen is accepting actually 2 electrons. Okay guys, listen carefully. Oxygen is accepting, okay. So yes, it is a dative bond. Through dative bond, okay, through dative bond, oxygen is accepting. This oxygen is accepting 2 electron. So accepting 2 electron means here I can again write -2. Okay, here I can again write oxygen order oxidation state is -2 for this oxygen. Okay. So when you consider nitrogen is getting +2. So this +2, this +2. So the total oxidation number of nitrogen is +4. I hope it's clear. Do you have any doubt? Any doubt, Ada? Shiva, Raghav, Bunny? I can understand, Bunny. I hope it's clear. If you want to write notes, no worries. You can write the notes, okay? No worries. But if you have any doubt or something, you can ask in the chat box, okay? Clear, ma'am? Yesterday itself, you told about coordinate bond. Yes. I hope it's clear. Yes. That's why I recommended Telugu. Okay, ma'am. Okay, now. So, guys, we are next moving to minimum and maximum oxidation number. Okay. So, here I am going to write minimum and maximum oxidation state. So, I am writing OS. OS means oxidation state. Okay, da? Minimum and maximum oxidation state. Okay. Chill. So, we can start. So, what is minimum and maximum oxidation state means? So, when you consider, so here we can first consider, yes, group 14. So, what is the general electronic configuration of group 14, Ada? What is the general electronic configuration of group 14? No, I'm not seeing Shiva bros chat. எல்லாரோட chat எனக்கு பார்க்க முடியும். ஓஹோ, I forget your number. I check name. Fantasy world ஓட name என்ன? Nila. Yes, Nila. Yes, Nila. Yes. NS2. Yes. NS2. So what is the general electronic configuration? NS2, NP2. Okay. So guys, what is the NS2, NP2? What is the minimum and what is the maximum oxidation state? Minimum and maximum oxidation state. What is the minimum and what is the maximum oxidation state of 14th group element? What is the minimum or what is the maximum oxidation state of group 14 element? Here I can see +2, +4. This is the minimum maximum oxidation state of group 14 element. Really guys, this is 2. It's look like 4. Now it's 2 alle. NP2. Now 2. It's look like, yeah, now it's look like 2. So I'm asking here, I can see, so listen carefully. So group number 14 means I will write the electronic configuration, that is 284. Okay. So here, minimum oxidation state, how to attain stability? Either it should attain 4 electron, okay, it should accept 4 electron, that means accept 4 electron means -4, or it should donate this 4 electron, okay, or it should donate this 4 electron, in the complete 4 electron donate pannanum, okay. So appo it can attain outermost shell 4 electron, outermost shell 8 electron, it can obtain like what? Octet, okay, it can obtain octet, okay. Either it should lose 4 electron or it accept 4 electron, okay. Either it should lose 4 electron or it should accept 4 electron. So the minimum oxidation state is actually -4 and the maximum oxidation state is actually +4, okay. Listen carefully guys. So minimum oxidation state is -4 and maximum oxidation state is +4. This is very important, okay. Ma'am, P block lecture la, yes, mentioned, yes, P block lecture la அப்படிதா இருந்ததடா. Yes, எனக்கு தெரியும், அதனால நீங்க +2 +4 னு சொல்லி இருக்கு. So அதுக்கு சான்ஸ் என்னன்னா, so it will give 2 electron from here, okay. It will give 2 electron from here, okay. So இந்த 2 electron கொடுத்தா NS2 ல ஸ்டேபிள் ஆயிடும், okay. NS2 ல ஸ்டேபிள் ஆயிடும். And இங்க என்னன்னா, so minimum and maximum சொல்லும்போது either 4 electron கொடுக்கணும் இல்லனா 4 electron accept பண்ணணும். அந்த like அந்த thought process தான் இங்க இருக்கு, okay. So எனக்கு தெரியும் நீங்க +2 and +4 சொன்னதுக்கு ரீசன் இதுதான். Yes, அங்க அப்படிதான் இருக்கு, okay. I hope it's clear. Okay, so different group, so I will tell you the reason. I hope it's clear. So different group க்கு different மாதிரி இருக்கும், okay. Different group க்கு different மாதிரி இருக்கும். So here you can see for plus, that means 14th group க்கு, so valence electron is 4, so it will accept either 4 electron or donate 4 electron, plus or -4, okay. When you consider 15th group, outermost shell 5 electrons are there. So minimum oxidation state enna? So minimum oxidation state, it can accept it can accept 3 electron or it can donate 5 electron, okay. When you consider 16th group, it can accept 2 electron or it can donate 6 electron. When you consider 17th group, it can accept 1 electron or it can donate 7 electron. I hope it's clear. இப்போ clear-ஆ சிவா clear-ஆ? Paka clear. Okay. Then we are moving to kerose acid. Okay. Oxidation state of S. Calculate the oxidation state of S. Yeah, definitely I will solve some PYQs also, da. No worries. You can see lots of answers. Plus 8, plus 6. Okay, we can check. So, this is actually kerose acid. Okay, this is actually kerose acid. This is very important. Okay, last question la ungalku oru butterfly structure solli irundhathu. So, same question ungalku 2026 la vandirukku. Okay, so here we can do. So, yes. Yeah. So, we can calculate. So, hydrogen is actually plus 1. So, how many hydrogen is there? So, 2 hydrogen is there. So, we don't know sulfur. So, I am taking it as X. Yeah. Plus oxygen. Oxygen is actually O5 no சொல்லும்போது 5 into minus 2. You will get 0. And here it is 2 plus x plus minus 10 equal to 0. X is equal to, you will get 8. Okay. So guys, here you can see sulfur எந்த குரூப்ல இருக்குடா? Sulfur எந்த குரூப்ல இருக்கு? Sulfurோட group என்ன? So what is the group of sulfur? Which group? So sulfur எந்த குரூப்ல place பண்ணியிருக்கு? Sulfurோட group என்ன? So tell me quickly. I can see here it is 6, 10 minus 2. Yes, correct only. 8. So tell me sulfur எந்த குரூப்ல இருக்குடா? Sulfur எந்த குரூப்ல இருக்கு? Come on. Group number 16. So here you can see this is the oxidation number. So we can check group number 16 la. You can see here maximum oxidation state is plus 6 and minimum oxidation state is minus 2. So here you can see sulfur oxidation state is actually 8. So it is not possible. Okay, it is not possible because sulfur எந்த குரூப்ல இருக்குடா? 16th குரூப்ல இருக்கு. Okay, 16th குரூப்ல இருக்கு. So இந்த மாதிரி molecules, okay, some molecules இந்த மாதிரி calculate பண்ண முடியாது. So here we will use the structure. Okay, here we will use the structure of that molecule. Okay, kerose acid oda structure என்ன? Sulfur. And here you can see OH, and next is actually 1O, here also H, 1O, OH, 1O, OH, and here it is double bonded O, and here also it is double bonded O. 1, 2, 3, 4, 5. Yes, this is the structure. So now calculate the oxidation number of Carose acid. Now calculate the oxidation number of Carose acid. Okay. So how we will calculate? So oxygen and sulfur like break பண்ணும்போது what you will get, oxygen is actually here -1 and sulfur is +1. Okay, sulfur is -1, oxygen is -1 and sulfur is +1. So here also in the bond break பண்ணும்போது oxygen is -2 here, double bond is there, so sulfur is +2 here, and here oxygen is -1, sulfur is +1. So if this bond break means, yes, oxygen is -2, sulfur is +2. So we can add all sulfur order, all oxidation number we can add. 1 + 2 + 2 + 1. Correct? 1, 2, 4, 5, 6. So correct answer is actually 6. Okay. +6 is the correct answer. I hope it's clear. By heart, by heart. No other option. Hansika, you should by heart the structure. Okay. So illama like Carose acid oda structure enakku illama proper idu ibdi varudhu abdi illa, so you should by heart the structure. Okay, no other option. You should by heart because உங்களுக்கு ப்ராப்பரா லாஸ்ட் டைம்ல சேம் டைப் ஆஃப் question வந்திருக்கு. ஓகே, சேம் டைம் ஆஃப் question உங்களுக்கு வந்திருக்கு. So that I will show you. Okay, so yes, then we are moving to, yes, this is the concept. So then we are moving to Marshall acid. Marshall acid is actually H2S2O8. Okay, Marshall acid. This is actually Marshall acid. So you can calculate the oxidation number of sulfur here. Oja, we don't have other option. You should by heart the structure. So by heart structure பண்ணலனாலும் உங்களுக்கு like Carose acid la, okay, Carose acid la maybe they will give a structure also. Okay, structure தந்தா easier you can calculate அல்ல, bond break பண்ணிட்டு. This is actually Marshall's acid. Marshall's acid. Yeah, okay, Oja. So what is the oxidation number of sulfur in Marshall acid? இதுக்கு that how to identify dative bond. நோடா dative bond இங்க dative bond இல்ல. ஸோ இதுக்கு dative bond நீங்கள் லைக் பண்ண வேண்டாம். இது உங்களோட டெக்ஸ்டில் இருக்கிற ஸ்ட்ரக்சர் மட்டும்தான், அது மட்டும்தான் கேட்கும். ஓகே, ஸோ இந்த ஸ்ட்ரக்சர் மட்டும் படித்தா போதும். ஓகே, ஸோ அவுட் ஆஃப் சிலபஸ் வராது. ஓகே, மார்ஷல் ஆசிட் எல்லாம் உங்களோட டெக்ஸ்டில் இருக்குது. எஸ், யூ வில் கெட் +6. So this is not the answer. So I will directly draw the answer. Okay, I will directly draw the answer. So sulfur, and here oxygen, here also oxygen, here OH, and here you can see O, and another sulfur, OH, O. This is the structure. Okay, so எப்படி calculate பண்ணலாமா? So now you can say, tell me what is the correct answer. This is the structure of Marshall acid. So tell me, we can break down the bonds, then you can calculate. Okay, break down the bonds and calculate the oxidation number. Come on, answer. Answer. Where is Shiva? Bunny? Hansika? As I think it is 5. Okay, you're saying 5. Oja. Zade. Zaid. Zaid or Zade? Ma'am, yes, so tell me, what is the correct answer for this answer? I'm here. So tell me, I'm asking the answer. One peroxide link is there. Okay. Come on. Oxygen bond is there. Thank you for Fatima. Where is Fatima? Yes. Ojal. Whereas I can't see Shiva. I can't see Takshan note எல்லாம் எழுதுதுன்னு சொல்லியிருக்கு. So I will check note. Okay. Takshan. So after the session, you should send the note. Okay. Okay, we can check. So yes, bond break பண்ணியிருக்கு. So here oxygen negative. So sulfur is actually positive 1. This is also oxygen minus 2, sulfur plus 2. So here also sulfur plus 2, oxygen minus 2. Yes. Here also oxygen minus 1 and sulfur plus 1. Okay. So here not necessary. So here we can calculate any one. Same structure only. Here you can see. So yes, plus 1 for this 1 plus 2 1 2. So you will get 2 2 4 5 6. So what will be the correct answer, Ada? Correct answer will be 6. Okay, correct answer will be 6 plus. Ada ma'am, if say incorrect then L. Again you will say like, Ada what? So I hope it's clear. It is plus 6. Then yeah, this is the Marshall acid. So yeah. So Marshall acid. Then we are moving to next molecule, that is butterfly structure, that is CrO5. Okay, CrO5 another exceptional case da. So இது உங்களுக்கு 2026ல எக்ஸாமுக்கு வந்திருக்கு. Okay, 2026ல எக்ஸாமுக்கு இந்த same structure வந்திருக்குடா. Same structure. Okay, same structure. This is actually butterfly structure னு சொல்லும். Okay, this is actually butterfly structure. Butterfly structure. Okay, so what is butterfly structure? I will show you. So Cr central irukku and inga oru O, again inga same here also and adukku oru antenna irukulla butterfly ki. So antenna yum irukku. So yes, 1 2 3 4 5. Yes, correct. This is the structure. So tell me, what is the oxidation number of chromium here? Calculate the oxidation number of chromium. So when you consider this, it's minus 1, this is plus 1, plus 1, plus 1, minus 1, plus 1, not plus 1, minus 1, plus 1, plus 2, minus 2. So 1, 2, 3, 4, 5, 6. Plus 6 will be the answer. Plus 6 will be the answer. I hope it's clear. So this is butterfly structure. உங்களோட 2026 NEET-ல in the same question வந்திருக்கு. Okay, cancel NEET-ல in the same question இருந்திருக்கு. Okay, yes, this is, it's look like butterfly. Okay, so இது butterfly ஓட wings, இது antenna. Okay, so then we are moving to yes, moving to next structure. Ella structure me important da. Okay, next structure, so that is also very important. That is, yeah, that is actually after butterfly structure enna important ah irukku. Just a second da. Yeah. So this is also very important. Okay. Oxygen 8, oxygen, CrO8. K3CrO8. What is the oxidation number of Cr? Oxidation number, or calculate the oxidation. In the molecules ellame important da, ellame exceptions da. Okay. Hello ma'am, Shiva. Yes, Shiva nu 100 times na call பண்ணிருக்கு. நீ இங்க இல்ல, நான் confirm பண்ணிட்டேன். Okay. So yes, what will be the structure of this molecule? Cr and here it is actually oxygen, idum oxygen, and here also it is oxygen with K. Okay, inga K plus irukku, inga K, and here 1 2 3 4 5 6 7 8. Okay, this is the structure. So you can calculate the oxidation number. Come on, calculate the oxidation number. Guys, this is very important. If you want to by heart, just by heart. So in the molecule oda oxidation number Kr varumbodhu idu oxidation number nu by heart பண்ணிக்கோங்க, no issues. Okay. You can see answers. So 1 2 3 4 5, yes. Plus 5 is the oxidation number. I hope it's clear. Clear alle? Clear. Then next molecule here you can see, this is the thing, plus 5. Next molecule, yes. Next is oxidizing and reducing agent. What is oxidizing and reducing agent? Ma'am, the structure look like what is that? Damarukam in Shiva's hand. Shiva's hand. Shulam. You are saying Shulam? Am I right? It's look like Shulam. Yeah. It's look like Shulam only. 3 lines. Okay. Yes, Shulam. Yes. So yes, guys. Next we are going to study about oxidizing agent and reducing agent. This is also very important. What is reducing agent? So itself, okay, the molecule itself undergo oxidation, that is actually reducing agent. Okay, itself undergo oxidation, that is actually reducing agent. Then what is oxidizing agent? So that molecule itself undergo reduction, that is oxidizing agent. I hope it's clear. So what is reducing agent? Which itself undergo oxidation, and what is oxidizing agent? Which itself undergo reduction, that is oxidizing and reducing agent. Okay, so here you can see an element in highest oxidation state. Okay, ஒரு element அதோட highest oxidization state la da irukku. So oxidation state can behave only as oxidizing agent. Okay, highest oxidation state la da irukku. Okay, highest oxidization state means obviously maybe when you consider group number 14 na, it is plus 4 la da irukku. Okay, highest oxidation state. So இதுக்கு என்ன பண்ண முடியும்? இதுக்கு actually electron accept பண்ண மட்டும் தான் முடியும். இதுக்கு அப்புறம் electrons donate பண்ண முடியாது. Agent which increase oxidation number, yes, well, oxidant. Okay. Dakshin, he is telling about damarukam, dum like instrument which is attached in shulam. Okay, that this I don't know, chenda, we will say chenda, am I right? I thought damarukam means shulam, that chenda. Dakshin, Dakshin, I call you lots of time. You are not there. Love you. Love you too. Yeah. Sharda, love you too. I don't know the Marukam. Okay. You was there. Okay. But I call you lots of time. Oh, Dakshin. When you call me. I called you. So ask to Navya is not there. Ask to like Bunny. You should teach Telugu. Okay, after NEET, I will take a course. No worries. Okay, you teach Telugu. Okay, Navya is also here. Yeah, I'm here. Yeah. Okay, yeah, come on, guys. So அதோட oxidation number, maximum oxidation number என்ன, highest oxidation number is +4. இதுக்கப்புறம் it can என்ன நடக்கும்? So இதுக்கு electrons accept பண்ண மட்டும்தான் முடியும். Okay, இதுக்கப்புறம் electrons donate பண்ண முடியாது. So an element in highest oxidation state can behave only oxidizing agent. Okay, it can only act as a oxidizing agent. What is oxidizing agent? Self reduction. What is self reduction means? Oxidation number will decreases. Okay, that means it will accept electron. Okay, it will accept electron. ఏం చేస్తున్నావు? That I know. ఏం చేస్తున్నావు? బన్నీ ఏం చేస్తున్నావు? బువ్వ తిన్నా మమ్మ. బువ్వ తిన్నవా మమ్మ? Had food? No. I want to. Yeah. Many of them are Telugu. I think here I can see very less Tamil students. Buva means rice. Buva, okay. Buva. Damaru, udukkai. Okay. That thing. Udukka. Yeah. I know that. Chenda. Yes, ma'am. Yes, ma'am. Tamil and Telugu. Okay, you are Tamil and Telugu. Any Tamil student? Any specific Tamil students are here? Any specific Tamil only students are here? Malayalam. Yes, I am Malayalam. Yes, not I am Malayalam. I am Malayali. I am pure Tamil. Oja, you are Tamil, ma'am. Pure Tamil. Fatima is pure Tamil. Bunny is not Tamil. That I know. Pure Tamil. Manju, I am here. Navya, raise hands, Tamil. Cheppu, Dakshin. Dakshin is also Tamil student. I am Tamil only student. Okay, Jai. I am pure Tamilian. Okay, Fatima, Jahi, Dakshin, Yuva. Yes, IPL bros. IPL இருந்து சென்னை அவுட் ஆயிருக்குல்லடா. I know Malayalam, but I am pure Tamil. Okay, you know Malayalam? Nice. No Tamil, only we need No Tamil, only we need Tamil Nadu. I am Tamil, ma'am. Okay. We speak all South Indian languages. Oh, it's so nice, Raghav. Cheppu means sollu. That I know. Cheppu, sollu. Sollu, no meaning. Okay. Cheppu, yes. Pure Tamil, Kannada. that I know. No, Navya's Kannada, pure Kannada. I can see Kannada students, Telugu students, Tamil students. Any other languages? Malayalam. I can speak Malayalam also, ma'am. Oh my God. Pure Hyderabadi biryani. Guy, ma'am. Oh, but you know, you don't know Tamil, I know. Yes. Okay, guys. Yeah, come on. Korean and, you know Korean and French. Oh, wow. Pookie students, pakka Pookies. Korean and French students. Pookie, I know Malayalam little bit, ma'am. Oh, Shamita, okay. Solla ma'am. Sollu ma'am. Yes, cheppu. I know bit Korean. Oh guys, you guys are really pookies. Okay, I know this 2K kids love Korean series, Korean dramas. It's really dramas only, guys. Ma'am, I know Tamil, Telugu, Malayalam, Korean, Odia, Arabic. Oh, Takshin, seriously? Seriously? Seriously, Takshin, from tomorrow, Takshin is my sir. I want to give Guru Dakshina for him. I want to learn Telugu, Korea, Odia, Arabic from you. I will learn. None was Hindi, but I know Hindi. Toda malum. Might be lying. We might be lying. Yeah, maybe there is chance. Takshin, please help, ma'am. Yeah, definitely I will help you. Ma'am, revaluation website is not opening, ma'am. Ada, don't worry. So you're doing alone or in some, like, some people are helping you. So because of Ada site maybe jam. Yes ma'am, I know. Okay. Sir, Takshin sir. Hindi also toda ma'am. Yes. Revaluation sizes on. Try da. So when is the last revaluation date da? When is the last revaluation date? Call customer care CBSE. Yeah, I promise. I know. Oh really? Yes. Genius Takshin, you know. Yeah, it's so nice. It's good. It's a good habit, okay? To learning 22nd. So today is 19th, alle. So don't worry, Ada. Don't worry. We have time. So just try, okay? And you can definitely give revaluation, okay? No worries. Okay. I will check and I will tell you. Okay. Okay. Raghav's polyglot. Yes. Okay, guys. Not Raghav, Takshin. Okay. Yeah, guys. So here you can see when you consider group 14th. So group 14th order maximum oxidation state is +4 and minimum oxidation state is -4. Okay. So idukku in the group 14th element, okay, suppose and the element already 14 like maximum highest oxidation state la irukku. Okay. So it can only behave as a oxidizing agent, reducing agent behave panna mudiyadu. Okay. I learned before my 10th itself, Shiva. Oh, really? That's nice. Yes. Okay, nice. So, when you consider KMnO4, so what is the oxidation number of manganese in KMnO4? It is actually +7. So, when you consider manganese order maximum oxidation state is +7 and minimum oxidation state is actually +2. Okay. So, this is the maximum and minimum oxidation state of manganese. So, here manganese is +7. Now, idukapra enna manganese ku electron donate panna mudiyadu. So, idukapra manganese ku enna electron accept panna mudiyum. Okay, accept panna mattunda mudiyum. Guys, stop. Bus. French is easy. Okay. So, here after that inga manganese ku electron accept panna mattunda mudiyum. Okay. So, manganese enna KMnO4 will act as a reducing agent. Okay, you can see not reducing agent, oxidizing agent, reduction will happen. Okay, oxidizing agent itself reduction will happen. Okay, itself reduction will happen and it is a oxidizing agent. Okay, so possible oxidizing agent. Okay, reduction only possible, oxidizing agent. Oxidation is not possible and it will not act as a reducing agent. Okay, it will not act as a reducing agent. I hope it's clear, Ada. Clear? I hope it's clear. Then same. Okay, so an element in the lowest or minimum oxidation state, it can act as a reducing agent. Okay, so when you consider CH4, okay, so here carbon order oxidation state it is actually -4. Okay, it is actually -4. So -4 is the minimum oxidation state of carbon. Okay, -4 is the minimum oxidation state of carbon. So here you can see itself, what will happen? Itself oxidation occurs means it will act as a reducing agent. Okay, it will act as a reducing agent. So oxidation is possible and it will act as a reducing agent. And oxidation is not possible. No, oxidation, not oxidation, reduction. There is some mistake. It's reduction, okay da? Reduction is not possible and it will not act as a oxidizing agent. Okay, it will not act as a oxidizing agent. Suppose, okay, so idoda oxidation value or oxidation state enna in between or intermediate oxidation state la irukuna, it can act as a oxidizing agent and it can act as a reducing agent. Why? Because itself undergo oxidation and itself undergo reduction. Okay, when you consider HNO2, so the oxidation state of HNO2 is actually nitrogen order oxidation state is actually +3. So +3 nu sollumbodhu, so enna reduction nadakkum, adukku oxidation nadakkum. Reduction itself, reduction means it will act as a oxidizing agent. Itself oxidation happening means, or oxidation occur means, it will act as a reducing agent. I hope it's clear. Then some important compound. Okay, some important compound. So adile important ana compound the carbon sulfoxide. Carbon sulfoxide means not sulfoxide, suboxide. Carbon suboxide. Carbon suboxide means C3O2 the carbon suboxide. So C3O2 la enna carbon oda oxidation number eppadi calculate panna, you will get 4/2. Okay, you will get 4/2. So guys, this is actually average oxidation state. Okay, this is the average oxidation state. So carbon suboxide oda structure idudha. Okay, so O double bond C double bond C double bond C 1 2 3 and again C 1 2 3 C. Okay, so this is actually carbon suboxide. Okay, this is actually carbon suboxide. So divide panni parunga. So divide பண்ணும்போது, so carbon oxygen will get -2, carbon will get positive, and இது homo like ரெண்டுமே same molecule. So இதுல 0 0 வரும், இதுலயும் 0 0 வரும். So என்ன இங்க like break பண்ணும்போது, so carbon oxygen will get -2 and carbon will get +2. Okay, so inga carbon oda oxidation number rendume calculate பண்ணும்போது it is +4. Okay, +4. So we know that how many carbons are there? 3 carbons are there. So +4/3. Okay, +4/3 is the average oxidation state. Okay, I hope it's clear. It is actually +4. So it is some important compound. Okay, carbon suboxide. And carbon suboxide மாதிரி வேற ஒரு important compound தான் tribromo octa oxide. Okay, tribromo octa oxide. So tribromo octa oxide la you can see Br3O8. Okay, so idile Br3 oda calculate என்ன oxidation number தான் calculate பண்ணனும். So you will get 16/3. So it is also average oxidation state. Okay, it is also average oxidation state. I hope it's clear. ஏதாச்சும் டவுட் இருக்கா? I hope it's clear. Okay, clear. So next is concentration terms. I will teach you in solutions. Okay, so idellame concentration terms da, so that I will teach you in solutions. And next is concentration terms. எல்லாமே concentration. N factor. This is very important. Okay. N factor. So before that I will give you ஒரு lunch break. Okay guys. Lunch break எவ்வளோ time lunch break வேணும்? So இப்போ almost 1 o'clock. So உங்களுக்கு ஏதாச்சும் டவுட் இருந்தா tell me. Okay. Yes, after this we will finish D and F block. Okay, first இது finish பண்ணிட்டு then we can start D and F block elements. Definitely I will finish D and F block elements also. 125. Okay. So everyone quickly smash the like button. I want to check. Yes. Yeah, it is. So okay. Ready, ma'am. Okay. So guys, so sharp 125 க்கு எல்லாரும் வரணும். Okay. Okay, bye bye guys. Hello guys. Yes, hello. Hello, hello, hello. Yes guys. Hello. So எல்லாரும் எங்க போச்சுடா? So hello. Yes. So 100 likes ஆயிடுச்சா? 52. Oh my god. Harshita, yes Harshita. வந்துட்டோம். Yeah, வந்துட்டோம். நானும் வந்துட்டோம். Just a second டா. So சாப்பிட்டாச்சா? இன்னைக்கு என்ன ஸ்பெஷல் இருக்கு? So did you had your lunch? Navya, Jahi, Shamita. Okay. Yes, நோடா. டைம் கிடைக்கலல. நான் இப்போ லஞ்ச் சாப்பிட்டா லைக் எகெயின் டைம் ஆகும். ஸோ அப்போ ஐ தாட் கிளாஸ்க்கு அப்புறம் ஐ வில் ஹாவ் ஃபுட். Okay, so next is actually N factor. Okay, N factor is very important in redox reaction. So acid, base, salt, charge and elements are N factors. Okay, so we can check, and reactions also. Okay, so when you consider acid, so what is N factor of acid? Guys, Kukka. So ellarum enga pochada? Hello. Noda, I want to. Ma'am, no ma'am, bua ready agala. Okay, rice ready agala. Okay, hi Akshaya. Hello Navya, Jahi, Shamita. So guys, acid or N factor we can check first. So actually N factor is the number of H plus ions given. Okay, so what all dissolve பண்ணும்போது இல்லனா normally it will donate H plus அல்ல. So N factor of acid means it is H plus ions given, or number of OH minus ion taken. Okay, OH minus accepted or H plus donated. That is actually N factor for acids. Okay, N factor for acids. So when you consider HCl, okay, HCl N factor is actually 1, HNO3 N factor is 1, H2SO4 N factor is 2. And when you consider different acid here, you can see, guys, this is very important. Okay, concept, like especially structures are very important. So here you can see H3PO4 la you can see N factor is equal to, N factor is actually 1. Okay, so N factor is 1. So N factor is not 1, N factor is 3. So here why 3 I will tell you. Here you can see this phosphorus is connected with OH. Okay, 3 OH. So in the OH la irundhu da H plus என்ன போகுது. So here the N factor is 3, and here you can see this is H3PO3. Okay, H3PO3. So here one side la you can see PH bond. Okay, in one side you can see PH bond, and other side you can see POH bond. So POH வரும்போது POH ல இருந்து தான் இங்க இருந்து என்ன H plus release ஆகுது. So here N factorial is actually 2. Okay, N factorial is actually 2. Here the N factorial is actually 3, H3PO2. Okay, why? Because here you can see 1 phosphor OH bond. Okay, phosphorus OH bond. And next is orthoboric acid. So when you consider orthoboric acid, that is H3PO3, H3BO3 or BOH thrice. Okay, BOH thrice. So இங்க உங்களுக்கு இங்க பார்த்தா தெரியும் when orthoboric acid react with water கூட react பண்ணும்போது obviously H3 னு சொல்லும்போது என்னடா H plus-உம் OH minus-உம் இருக்கும். ஓகே H plus-உம் OH minus-உம் இருக்கும். so இங்க என்ன நடக்கும் இந்த OH என்ன இங்க OH இந்த என்ன orthoboric acid actually accept one OH minus. Okay, orthoboric acid actually accept one OH minus. Then you will get BOH 4 times. Okay, BOH 4 times minus plus H. So guys, here you can see orthoboric acid is accepting one OH minus. So N factor is actually 1 here. Okay, N factor is actually 1 here. Okay, N factor is actually 1 here. Yeah. Then you can see different acid. Yes, H3PO4. Okay, H3PO4. It is reaction. Okay, so H3PO4 is reacting with NaOH. Okay, sodium hydroxide kuda react பண்ணும்போது here you can see NaH2PO4. That means what will happen here உங்களுக்கு இங்க பார்த்தா தெரியும் it is accepting. Okay, it is accepting one. So இங்க என்ன it's releasing OH. Okay, it's releasing OH and H3 இங்க இருந்து hydrogen ஒரு one hydrogen release ஆயிருக்கு. One hydrogen, listen carefully, one hydrogen release ஆயிருக்கு. You can see. So this H3PO4 donated or released one electron. So what will be the N factor? Obviously the N factor will be 1 because it loses one hydrogen. Here you can see H3PO4 is reacting with the 2 sodium hydroxide. Okay, 2 moles of sodium hydroxide. Then you can see here Na2HPO4. Okay, Na2HPO4. That means here it is releasing 2 hydrogen. Okay, it is releasing 2 hydrogen. So releasing 2 hydrogen means N factor is equal to 2. Here you can see same H3PO4 is reacting with sodium hydroxide. You can see here H3HPO4. That means here it is actually releasing 3 hydrogen. Releasing 3 hydrogen means what will happen? So it's not H3. It is wrong. This is wrong. You will get what I'm so you will get actually Na3PO4. Okay, Na3PO4. That means it's releasing 3 hydrogen. So releasing 3 hydrogen means N factorial will become 3. Okay, N factorial will become 3. Okay, so I hope it's clear. Then next is for bases. Okay, that is for acids. Then next is for bases. So when you consider acid means H plus release பண்றது இல்லனா OH minus accept பண்றது. So what is bases means? So here OH minus given or H plus taken. Okay, OH minus given or H plus taken. So here you can see NaOH. Okay, NaOH oda N factor is actually 1. And because NaOH, when NaOH dissolve in water, it will form Na plus and OH minus. Okay, Na plus and OH minus. So obviously N factor is 1. And when you consider KOH, K plus and OH minus, so the N factor is 1. So because it release one OH. Okay, and when you consider CaOH twice, and here also the N factor is actually 1. Okay, the N factor is actually 1. And when you consider, so if dissolve in water, yes, it will donate 2. Okay, N factor is actually here it is 2. So NH4OH, when dissolve in water, it will release 1 OH minus. Okay, it will release 1 OH minus. So guys, then we are moving to for salt. Okay, so when you consider salt, so we know that salt means positive charge is there, negative charge will be there. So total positive charge or total negative charge, that is actually N factorial for salt. Okay, here you can see NaCl. So Na plus and Cl minus. N factorial is either you can take positive or negative. So n factorial is 1. When you consider MgCl2, MgCl2 means Mg is actually plus 2, and we know that for 1 Cl it is minus 1. For 2 Cl, total negative charge, it is minus 2. Okay, so you can write the n factorial is equal to 2. Okay, so next Al2SO4 thrice. So the n factorial is 6 here. Okay, so total positive charge when you consider, I will write here Al2SO4, Al2SO4, SO4 thrice. So we know that for aluminium means for 1 aluminium it is plus 3. Okay, for 2 aluminium means it is plus 6. Okay, so what is n factorial? It is 6. Okay, the n factorial is actually 6 here. Okay, I hope it's clear. Then we are moving to element. So elements order n factorial means n factorial is the valency. Okay, element order valency the n factorial. Okay, so valency is actually n factorial for elements. Okay, so then when you consider reactions, okay, n factorial for reaction, listen carefully. So we know that KMnO4. So what is the oxidation number of manganese in KMnO4? It is plus 7. Okay, it is plus 7. So here we know that acidic mediathila react பண்ணும்போது it will give manganese plus 2. Okay, manganese plus 2. If it is reacting in neutral medium, you will get Mn plus 4. Okay, and if it is in basic medium, you will get Mn plus 6. Okay, so இதுதான் என்னடா manganese இல்லனா KMnO4 ஓட acidic mediathila இல்லனா basic mediathila இல்லனா என்ன neutral mediathila இருக்கும்போது வர்ற change. Okay, oxidation number ஓட change. So how we will calculate n factorial? How we will calculate n factorial? So guys, இங்க oxidation number, the change of oxidation number into number of atom. Okay, so what will be the change of oxidation number from 7 to plus 2? Okay, plus 7 to plus 2, change is actually 5. Okay, change is actually 5. And how many manganese atom is there? Only one manganese atom is there, so the n factorial is 5. Okay, so when you consider in basic medium, in neutral medium, first we can consider neutral medium. Okay, when you consider neutral medium, so we know that manganese is actually plus 7 and manganese here is actually plus 4. So what is the difference? Plus 4, plus 5, plus 6, plus 7. Okay, 3 is the difference. So 3 into how many manganese is there? Only one manganese is there, so 3. So when you consider in basic medium, okay, when you consider in basic medium, what will be the like change in oxidation number? So I am writing here it is plus 7, here it is plus 1. Okay, the change is actually 1. 1 into how many manganese is there? Only one manganese is there, so n factorial is 1. I hope it's clear. So reaction le eppadi n factorial change agudunu theriyudilla. So that means summation of charge in number of like charge in oxidation number into number of atoms. Okay, change in not charge, it's change. Here it's written charge, it is change in. Okay, change in oxidation number into number of atoms. Okay, change in oxidation number and number of atoms into number of atoms. So here I will give you one example. Okay, just a second. Maybe 3 to 3:30. got a call from my manager. Yeah. So here I'm giving the same example, okay? Not this one. Okay, so here you can see FeC2O4, okay? So we know that, and here you are getting Fe3 plus and CO2, okay? So idhilirundhu you can calculate, okay? You can calculate, yeah, oxidation number, okay? Oxidation number of Fe, okay? Fe and C3, okay? Fe and C2, okay? Oxidation number calculate பண்ணும்போது actually you will get +3 and +2, okay? +3 and +2. And iron, here the oxidation number of iron is actually +3, and here carbon order oxidation number is actually +4, okay? Carbon order oxidation number is actually +4. So how we will calculate n factorial? So it's very simple. Change in oxidation state, okay? Change in oxidation state, it is +2, it is +3. So obviously it is 1 into and number of atoms. So number of atom, here you can see only one iron is there, okay? One iron is there, so you can write 1, okay? You can write 1. So when you consider carbon, okay, carbon, here it is +3 and here it is +4. So you can write what is the change between oxidation number is actually 1 into 2, it is equal to 2 means atoms. How many carbon atom is there in reactant side? It is 2, okay? So you can write 1 into 2, so you will get 2, okay? So overall n factorial. So when you consider a reaction, so for a reaction you should write overall n factorial, okay? For reaction you should write overall n factorial. So overall n factorial is equal to 1 plus 2, so you will get 3, okay? 1 plus 2, you will get 3. I hope it's clear. And next is disproportionation. Guys, what is disproportionation reaction? Tell me, what is disproportionation reaction? Yes, we can apply this same thing. Yes, disproportionation reaction. So tell me guys, what is disproportionation reaction? Reaction in which some element undergoes oxidation and reduction simultaneously, okay? So that is actually disproportionation reaction. For some element, okay, it will undergo oxidation and it will undergo reduction simultaneously, okay? Same element or same reactant, okay, same element will undergo oxidation and reduction simultaneously. That element or that reaction is actually disproportionation reaction. Yes, very good. Yes, same element undergo redox reaction. Yes, very good, Ada. Okay, so that is actually disproportionation. How we will calculate n factorial for disproportionation reaction? So that is very simple. N factorial, nf is equal to n1 into n2 divided by n1 plus n2. Okay, so n1, n2 means that is this, like n factorial of one compound, okay? So oxidation, reduction. So here we can do one question, okay? Yes, I don't know what reaction is that. Chlorine reacting with NaOH. Chlorine reacting with NaOH, yes. So you will get NaCl and NaHO also. So you can write, try, okay, just try this. So we can try together. So how will you should find, okay, which NaCl. NaCl, NaCl, NaCl and NaClO. Okay, NaClO. So here you can see oxidation and reduction. It's a disproportionation reaction. Okay, so yes, this, and for this one also. Okay, so we can write. So when you consider Cl is forming NaCl means what is the oxidation number here? We know that here it is 0. So what is the oxidation number of Cl in NaCl? What is the oxidation number of Cl in NaCl? So tell me quickly, what is the oxidation number of Cl in NaCl? What is the oxidation number of Cl in NaCl? So it is -1 and it is +1. Okay. So what is the oxidation number of Cl in NaO? NaClO. So tell me, you can write. What is the oxidation number of NaClO? What is the oxidation number? You can calculate. Okay. I will calculate here. +1 -2. Yes, +1. Yeah, got it. So tell me your answer. Yes, it is +1. Yes, correct. It is +1 because we know that Na plus is actually, I will use another color. Yes, Na is actually +1 and oxygen is actually -2. So Cl is actually +1. Okay, I hope it's clear. Clear, Aleda? Any doubt? Clear. So you can, so here Na from 0 to -1. So oxidation number is decreasing. So it is reduction. Okay, it is reduction. So it is reduction. So chlorine is forming here 0 to +1. Oxidation number is increasing. So it is oxidation. So how we will calculate it? How we will calculate this? How we can calculate this? So you can calculate n factorial. Okay, how we will calculate n factorial? So here what is the difference between oxidation number? The difference between oxidation number is actually 1 into how many chlorine atom is there? Only 1. So it is equal to 1. Okay, so the n factorial for the reduction is actually 1. So you can check oxidation n factorial. So n factorial is equal to, so chlorine is 0 and here it is chlorine is +1. Okay, so the change is actually 1 into how many number of chlorine is there? Only 1 chlorine is there. So you can write 1 into 1, you will get 1. Okay, so n factorial. Okay, n factorial oxidation and n factorial of reduction is actually 1. So how we will calculate? We know that equation, n1 into n2 divided by n1 plus n2. So here I am writing 1 into nf is equal to n1 into n2 is equal to n1 plus n2. So here I can write n1, everything is 1 into 1 divided by 1 plus 1. So you will get 1 into 1 divided by 2. Okay, you will get 1 by 2. 1 by 2 is the n factorial value. Okay. Oh guys, there is a mistake. Okay, I want to balance this reaction. So here I am writing 2. Okay, so I want to balance this reaction. So 2. Yes. So then I want to change here the number. Okay, so we know that 2 into, okay guys, 2 into 1. Okay, here also it is 2 into 1. Okay, so then I will change here 2 into 1, 2, you will get here also 2. Okay, because here 2 chlorine is there. 2 chlorine is there. Okay, 2 chlorine is there. So I forget to balance the equation. So you should balance the equation. So 2 chlorine is there. So 2 chlorine means you can write it here. 2 into 2 divided by 2 plus 2. 2 into 2 is actually 4. 4, 2 into 2, 4. Yes. Yes, 2 plus 2, 4. So you will get 1. Am I right? Am I right? Am I right? Yes. Add fire. Yeah, guys, I really need energy, Ada. I really need energy. So I hope it's clear. Jahi, yes, Jahi is back. So I thought இப்போ இது எப்படி கிடைக்கும்னு clear இல்லடா? இது எப்படி கிடைக்கும்னு clear இல்ல? Next is equivalent weight எல்லாமே we can Next is equivalent weight. Equivalent weight is also very important. Equivalent weight is equal to molar mass into n factorial. Okay, equivalent, how we will calculate equivalent weight? Molar mass into, yes, 4 by 4 is 1 only. So, yes, equivalent weight is equal to molar mass divided by n factorial. That you can calculate. Next is very important, balancing of redox reaction. Okay, how we will balance a redox reaction? So, here you can see it's a general equation. A plus B is giving C plus D. Okay, A plus B is giving C plus D. So, here the n factorial of A is NA. Okay, sorry, NF. So, here I am writing n factorial of A and B. Okay, so it is the n factorial of B. Okay, so here you can see how we will first you should calculate n factorial of A and n factorial of B. Okay, then the second step is balance all. Okay, balance all elements. Okay, except oxygen and hydrogen. Okay, you should balance all the elements except oxygen and hydrogen. That is the second step. Then you should, third step. Okay, we can move to third step. So we should balance oxygen and hydrogen in third step. Okay, first we are going to balance oxygen by adding water. Okay, by adding water to deficient side. எங்க oxygen deficient irukko, that side la we can add oxygen, water. Okay, that side la we can add H2O. Okay, so direct oxygen add பண்ண முடியாது. So இல்லனா coefficient la change பண்ண முடியாது. You should add water in the deficient side. And next is acidic or neutral medium. Okay, in case of, we know that acidic medium is there, neutral medium is there, and basic medium is there. So when you consider acidic or neutral medium, add H plus to the deficient side. Okay, if it is acidic or neutral medium, you can add H plus to the deficient side. Okay, you can add H plus to the deficient side. If suppose if it is a basic medium, okay, suppose if it is a basic medium, you can add H2O in the deficient side. Okay, you can add H2O in the deficient side. Okay, so an equal number of OH minus to the opposite side. So நீங்க எவ்வளோ H2O add பண்றோம், so opposite side la you can add that much OH minus ions. Okay, you can add that much OH minus ion. So for example, here you can see 4OH. So I will write here 4OH and 4H2O இருக்குன்னு நினைச்சுக்கோ. Okay, so here we know that 4OH and hydrogen. So எங்க hydrogen deficient இருக்கோ, so இல்லனா here like I will write here. Okay, 18 hydrogen giving 14 hydrogen. Okay, so இந்த sideல தான் deficient இருக்கு. Okay, in the side la da, because here you can see 18 hydrogen is there, here you can see 14 hydrogen only it's there. So it is the deficient side. So we can add, okay, how many hydrogen is necessary to balance this reaction? So we know that 4 more hydrogen is necessary to balance this reaction. So we can write 4H2O. Okay, you can add 4H2O. So that's the same number of OH minus ion you can add in the opposite side. So that means 4OH minus. Okay, if you are adding 4H2O, you can add 4OH minus in the opposite side. Okay, you can't directly add H plus or nothing. Okay, because it's basic medium, you can't add H plus. Okay, so I hope it's clear. Then I will give you a question. Okay, then I will give you a question. Just a second, I want to check question. Okay, I want to take question from here. Question. Yeah, question. So here is, I will give you one question. So the question is MnO4 plus I minus plus H plus gives, start from here, okay, MnO4 minus plus I minus plus H plus gives Mn2 plus I2 plus H2O. Okay, so you can try this. Okay, try the question. First you should calculate n factorial, and if you are getting n factorial, you can multiply that number with, you can write that number as a coefficient. Come on. Try this, try the question. Come on, calculate the n factorial. So manganese MnO4 minus means we know that for oxygen it is actually -2. So for oxygen X I am taking X plus -2 into like how many hydrogen is how many oxygen is there? 4 oxygen is there. So equal to -1. Okay, because we know that already charge is given, so -1. So you can write X plus -8 equal to -1. Okay, X plus -1. So here I am writing X is equal to minus it will become 8 minus 1, so you will get 7. Okay, am I right? No. No. Okay. What is the difference? So correct ledda. So you will get MnO4 minus oda idile Mn manganese oda oxidation number is actually 7, and here the manganese oda oxidation number is actually +2 da irukku. So +2 paakumbodhu difference evlo varudhu? So we should calculate NF value. So NF value eppadi calculate pannalam? What is the difference between +7 and +2? It is 5. 5 into how many manganese is there? Only one manganese is there. So NF factor is, that means N factor is 5. Okay, so the N factor is 5. Here the N factor, what will be the N factor? It is -1 and here it is 0. So -1 and here it is 0. Here it is 0 and here it is -1. So we know that only one ion, here only one iodine is there, okay, only one iodine is there means n factor is equal to 1 into 1 into and difference is also 1, okay, 1 into 1, so you will get 1. So the n factor is actually here it is 5 and here it is 1, okay, here it is 5, here it is 1. So உங்களுக்கு n factor கிடைச்சா நீங்க next step என்ன பண்ணணும், so இதோட n factor இது வெச்சு multiply பண்ணணும், இதோட n factor இது வெச்சு multiply பண்ணணும். So next stepல you can write 1 MnO4 minus plus 5I minus plus H plus gives Mn2 plus I2 plus H2O. So first step clear alla, first you should find the n factorial value. So n factorial value you should do cross multiply with the reactants, okay, reactant n factorial value cross multiply பண்ணனும் reactant வச்சிட்டு. So here you will get n factorial value is 5, so you can cross multiply with the I2, so 5I minus you will get, here you will get 1, n factorial value is actually 1, so you can multiply with MnO4 minus, so the value is actually 1 MnO4 minus plus 5II plus H plus gives Mn2 plus, okay, that is the first step, okay. So rewrite பண்ணிட்டே equation. Do you remember the second step? What will be the second step? Except hydrogen and oxygen, we should balance all the other atom, okay, except hydrogen and oxygen. So we can balance this. So manganese 1 1. So iodine 5. So I am writing MnO4 minus plus 5 iodine plus H plus. Here I am writing Mn only, here you can see only 1 Mn, so here I am writing 1 Mn only. So plus 5 iodine is there, okay, 5 iodine is there. So I am writing here I am writing 5 iodine means 5 by 2, okay. So here you can't write directly 5, okay, you can write 5 by 2 I2 plus H2. So manganese 1 1 and iodine 5, here it is 5 by 2 because here you can see it is iodine is actually I2 formula irukku, okay, you can yes Bala, I'm only seeing this lecture. Yes, definitely ada இந்த chapterல இருந்து இந்த like concept மட்டும் தான் வரும், இதுக்கு அப்புறம் ஒண்ணும் வராது, okay. So then if you balanced all the atom other than hydrogen and oxygen, adukapra we should balance hydrogen and oxygen, okay, you should balance hydrogen and oxygen. So eppadi balance பண்ணனும், so do you remember, so balance except hydrogen and oxygen, now you should balance oxygen by adding H2O, okay. So deficient side la hydrogen oxygen deficient side la you can add H2O, okay. So you can add H2O in the deficient side. So deficient side, how many hydrogen is there? Only 1 hydrogen. Here 2 hydrogen is there. So or if it is if hydrogen oxygen, okay. So here you can see only 1 oxygen, here there is no oxygen, here you can see 4 oxygen and 1 oxygen. So yeah, third step, okay, just checking, 4 oxygen to 1 oxygen. So MnO4, you can see 4 oxygen is there, okay, plus I minus 5I minus plus H plus gives Mn2 plus 5 by 2 I2 plus deficient side la deficient, that is the deficient side because here you can see 4 oxygen, here you can see only 1 oxygen, okay. So deficient side la you can add water, okay. So here I am adding 4 water, 4, yeah. So 4 water molecule I am adding, okay, 4 water molecule I am adding. So now oxygen is balanced, okay, oxygen is balanced. Now I want to check hydrogen, okay, now I want to check hydrogen. So here you can see only 1 hydrogen is there and here you can see 4 into 2, yes, 8 hydrogen is there, okay. Here you can see only 1 hydrogen, here you can see 8 hydrogen is there. So I should balance hydrogen. How should I balance hydrogen ada? Hello Sumitra, yes Sumitra, how should I balance hydrogen? So guys, here you can see it is a acidic medium. H plus is there. So H plus is there means it is a acidic medium. So how should I balance? So acidic mediathula H plus eppadi balance pannanum? By adding H plus. Okay, by adding H plus. So here you can see 4 hydrogen is there, only 1 hydrogen is there. I can write 8. So it is the balance form of this equation. Complete item. So இப்படி தான் reaction balance பண்ணணும். You can expect one question from balancing. Okay, definitely balancingல இருந்து ஒரு question வர்றதுக்கு chances இருக்கு. Okay, because redoxல இருந்து 2026ல last question வந்தது structure base பண்ணிட்டு தான். Okay, so butterfly structure இருக்குல்ல, so butterfly structure base பண்ணிட்டு குரோமியத்தோட oxidation number தான் நமக்கு கேட்டிருக்கு. So இந்த வாட்டி மேபி இந்த டாபிக்ல இருந்து சான்சஸ் இருக்கு question வர்றதுக்கு. ஓகே, பேலன்சிங்ல இருந்து question வர்றதுக்கு சான்சஸ் இருக்கு. ஓகே, so yes, then we can move to our next topic. You can do homeworks இருக்கு. So balancing questions ஓட. Then guys, I will give you some share. Yes, we are moving to next chapter, D block elements. Okay, D and F block elements. D and F block elements. So guys, so உங்களுக்கு D and F block elements பத்தி என்ன தெரியும் சொல்லுங்க. So what do you know about D and F block elements? So tell me quickly guys. So yes, Fatima, Jayshankar, Bhuvani, come on. I want very interactive class, ada. What is time now? Okay. So when you consider D block elements, yes, transition elements, yes, very good, transition elements. Why we are calling transition element? You know what is the reason why we are calling D block elements as transition element? What is the reason, Ada? Why we are calling D block elements as transition elements? For coordinate form coordinate compounds, and they what are transition elements form coordinate. Yes, it will form coordinate compounds. Very good. Which lie between S and P. Very good. Yes, you can see it is situated in between S and it is placed in between S and P block elements. Okay. Yes. Variable oxidation state. Very good. Variable oxidation state. Any other points? They have incomplete d orbitals. Okay, they have incomplete. So is every D block elements have incomplete d orbital, or any exception is there? Any exception is there? Formation of colored compounds. Yes, very good. It will form colored compounds. Yes, very good. No other points. Okay, so I will tell you. So we know that from 12 to what I am saying, 2 to 12 vada 2 to 13 varaikku you can see my brain is not braining ada. Yes, yeah, I can see exception is not only zinc ada. So there actually all 12th group elements, that means zinc, cadmium, mercury is the exception. Okay, exception. Okay, ellame exception da. So zinc, cadmium, mercury exception da. Okay, we can't say that zinc, cadmium, mercury transition element na solla mudiyadu. Okay, we can't say that. Okay, zinc, cadmium and mercury. So from group number 3 to 12 வரைக்கும் தான் என்னடா D block elements இருக்கு. Okay, D block elements you can see from group number 3 to 12 வரைக்கும் இருக்கிற elements தான் D block elements. Okay. So, D block elements oda first. Normally we will say D block elements are transition elements. Okay. So, why we are saying D block elements is a transition elements? Why we are saying D block elements are transition elements? So, that I will tell you the reason. Here you can see. So, S block irukku and P block irukku. They are main groups. Okay. Normally we will say it is main groups or representative elements. Okay. So, and the main groups la irundhu, okay, S la irundhu P la, okay, normally we will say when you consider reaction, okay, or reaction varumbodhu or transition state varunu sollula. So, yes, transition states are forming. So, same here also, okay. You can see in a P block la S la irundhu P la pogumbodhu you can see a transition is here, okay. You can see a transition. So, that is the reason here we are calling D block elements a transition elements. And one more point. So, we know that total 40 elements are there. When you consider D block elements, so D block elements la 40 elements irukku. Okay, 40 elements irukku. And in the 40 elements oda speciality enna, normally D block elements na ennada? D block elements na transition elements means, okay. Transition elements means it is actually D subshell should be partially filled irukanu. Okay, D subshell partially filled irunda we can say, not completely filled, partially filled irukanu. Okay, partially filled D subshell. Okay, D subshell partially filled irukanu, then only we can say partially filled D orbitals. Okay, then we can say it is orbitals. Okay, partially filled d orbitals irunda mattumdhan we can say it is transition, that is transition elements. Okay, transition elements means it should be partially, it should contain partially filled d orbital. Okay, it should contain partially filled d orbitals. Okay, so here you can see their properties are transition between, yes, their properties are transition in between properties of S block elements and P block elements. So, S block element la irundhu P block element la pogumbodhu adoda property la oru transition nadakudhu. Okay, so and the elements ku and the property la oru transition you can see. So, that is the reason we are saying it is transition elements. Okay, and transition elements which have partially filled, okay, it's very important, transition element which have partially filled n-1 d orbitals. Okay, it should have n-1 d orbitals in their ground state or their stable oxidation state. Either ground state la illana stable oxidation state la it should contain in a partially filled n-1 d orbital. Okay, partially it should contain, then only we can say yes, it is a transition element or transition metal. Okay, so when you consider D block elements la ella elements so they are metals. Okay, completely they are metals. So when you consider cadmium, zinc and mercury. Okay, so cadmium and copernicium. Okay, copernicium is also there. So when you consider so here I will write, okay, here I will write, when you consider zinc, what is the atomic number of zinc? What is the atomic number of zinc? So tell me, what is the atomic number of zinc? So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, 4s2, 3d10 is the electronic configuration of zinc. So here you can see the oxidation, the outermost shell. Okay, the D subshell is actually fully filled. Okay, it is actually the ground state. Okay, this is actually ground state. Suppose oxidation state la, okay, ஏதாச்சு oxidation excited state la enna nadakum? Obviously zinc will form Zn2+. Okay, zinc will form Zn2+. 2 electron enga irundhu pogunda? 2 electron in the S la irundhu da. Okay, 4s la irundhu da 2 electron pogum, then also it will form 4s0 3d10. Okay, 4s0 3D10 தான். Okay, I hope it's clear. So அதோட common oxidation state லையும் you can see, okay, stable oxidation state லையும் you can see Zn 3D10 தான் இருக்கு. Okay, Zn 3D10 தான் இருக்கு. So same cadmiumத்திலையும் mercuryலையும் coperniciumத்திலையும் அதுதான் exception. Okay, so exception எங்க இருக்கு? So may they will ask. Okay, so we know that 40 total number of D block elements. So just write in the chat box total number of D block elements and total number of transition elements. So we know that total number D block element is actually 40. So transition number of transition elements oda number evloda? Number of transition elements. You can write number of transition elements. You can write number of transition elements. Just write number of transition elements. Come on. Srimukhi 40. 40 number is actually transition elements. 36 I can see. If you want I will show you the image. This is actually transition elements. Not transition, D block elements. Yes, very good. I can see. Yes. So that is actually 40 minus. So this is actually D block elements. So 40 minus. So 1, 2, 3, 4. 4 பண்ணும்போது you will get 36. Okay. So you will get 36 elements. 36 transition elements are there. Okay. So next. Okay. So here scandium, iron and zinc and zinc 2+ order electronic configuration they are writing. Okay. So if you want I will write again. So if you want I will write again. Otherwise I will explain here. Okay. When you consider scandium, scandium is actually atomic number 21. So argon 4s2 3d1 தான். So guys scandium speciality என்னன்னா, so இங்க இருந்து 3 electrons போயிடுச்சுனா, okay, it will form, okay, 3 electron போயிடுச்சுனா என்ன, scandium will become stable. Okay, scandium என்ன +3 oxidation, it will show +3 oxidation. Scandium will show +3 oxidation state. When you consider iron oda oxidation state என்னடா, so we know that atomic number is 26, argon 4s2 3d6. Okay, so here in oxidation number, okay, this is the general oxidation number of iron. And zinc 0 irukku. So this is actually already we wrote this electronic configuration. Argon 4s2 3d10. Suppose in Zn 2+ nu சொல்லும்போது இங்க 4s ல இருந்து 2 electron என்ன போகும். Okay, 4s ல இருந்து 2 electron போகும். It will become stable. Okay, so yes. So then also here you can see 3d is fully filled. Okay, it's not partially filled, it is fully filled. It is fully filled means we can't consider it as a transition element. Okay, we can't consider zinc as a transition element. I hope it's clear ada. Same zinc, cadmium, mercury and copernicium are not transition element. Why? Because adoda outermost shell la, that means adoda 3d la 10 electrons are there. Okay, so adoda 3d orbital is actually fully filled. Okay, and guys here already mentioned D block elements actually 40 தான். Transition element எவ்வளோ இருக்கு? 36. Okay, 36. And guys உங்களுக்கு என்ன electronic configuration இல்லனா electronic configuration by heart பண்ணனும்னா, so ஒரு trick இருக்கு. Okay, I will write here. Okay, I will write here. So Shyam Pandit Shyam Daddy Pandit Shyam, Father Daddy Pandit Shyam, Father Daddy Pandit Shyam, Father Daddy Pandit Shyam, Father Daddy Pandit Shyam. Okay, Shyam Pandit Shyam, Pandit Shyam, Father Daddy Pandit Shyam, Father Daddy Pandit Shyam. I hope it's clear. So we can start from S la 1, இது again 2, this is 3, this is 4, this is 5, this is 6, this is 7. Okay, so adukaprom we can write என்ன P பண்ணும்போது, so P starting in 2 ல இருந்து தான் P start பண்ணும். அதுக்கப்புறம் 3 4 5 6 and அதுக்கப்புறம் D. Where is D? Yes, D இங்க தான் இருக்குல்ல. So D என்ன D1 2 and D யும் எங்க இருந்து ஸ்டார்ட் ஆகும் 3 ல இருந்து. So 3 4 5. And what about F? F enada? So F is actually 4, 5. 5. No, not 5. 4. 4, 5. So this is the order. Okay, உங்களுக்கு by heart ஏதாச்சு like doubt வருதுன்னா so you can follow this. Okay, Sham Pandicham daddy Pandicham father daddy Pandicham. I hope it's clear. Guys, is it clear? Guys, is it clear? Clear ada? Is it இல்ல? இதுக்கப்புறம் forget பண்ண மாட்டேன்ல? So yes. So here you can see normally first we will exception னு சொல்லும்போதே first we will think about two exceptions, copper and zinc or exception. Okay, copper and zinc. Okay, so here I will show you all the exception together. Okay, so when you consider 4D series, okay, 3D series la da enna two exceptions irukku. One is copper and another one is chromium. Okay, chromium and copper oda first exception 3D series la da. So adu ungalku proper ah theriyum nenaikira. So because enna 1 electron 4s la irundhu vaangu. Okay, so stability attain பண்றதுக்காக. Okay, we know that half and fully filled orbitals are half filled and full filled. D orbitals are more stable. So அதனால என்ன S ல இருந்து 1 electron வாங்கி stable ஆகும். Okay, yes, when you consider 4D series. Okay, 4D series consider பண்ணும்போது so we know that எப்படி krypton வச்சு தான். Okay, 3D series ல நம்ம நார்மலி ஆர்கன் வச்சு தான் ரெப்ரசென்ட் பண்ணோம். இங்க 4D சீரீஸ்ல கிரிப்டன் வச்சு and 5D சீரீஸ்ல xenon வச்சு. So here you can see எவ்வளோ எலிமெண்ட்ஸ்ல எக்ஸெப்ஷன்ஸ் இருக்குன்னு. ஓகே, இதுல 4D சீரீஸ்ல எக்ஸெப்ஷன் இல்லாத எலிமெண்ட் ஒன்னு கேட்மியம், zircon and Y. Okay, so 3 elements மட்டும் தான் எக்ஸெப்ஷன் இல்லாத எலிமெண்ட்ஸ். ஓகே, பாக்கி எல்லாத்துக்குமே என்ன இருக்கு? You can see exception. Okay, so yes, இங்க என்ன நடக்குது? Normally 5s2 you can see I will yes you can see 5s2 தான் வரும் and 5s2 3D 4. But what will happen? 5s will give 1 electron to 4D. Okay, 5s will give 1 electron to 4D, then it will form 5s1 4D4. Okay, so when you consider molybdenum 5s2 same. Okay, 5s2 2 ல இருந்து 1 electron என்ன 4D க்கு கொடுக்கும். So it will form 4D5 and 5s1. Okay, 5s1. So and my dear students, 4D series ல important, okay, important ஆன compound தான் palladium. Palladium is very important. Normally palladium exceptions of exception னு தான் சொல்லுவோம். Okay, palladium is called exceptions of exception. Why? Because 5s2 4D 8 தான் இதோட normal general electronic configuration. But the exception of exception னு call பண்றதுக்கு reason என்னன்னா, here you can see normally எல்லா 5s ல இருந்தும் 1 electron will give to 4D. Okay, எல்லா 5s ல இருந்தும் like most of the எல்லா exception இருக்கிற 5s ல இருந்தும் only one electron give to 4D. But here you can see in case of palladium the 5s electron, 5s 2 electron. Okay, we know that 5s contain 2 electron. That 2 electron will give to 4D. Okay, so 5s 0, it will become 5s 0 4D10. Okay, we know that. So 10 means D10 means it is more stable. Okay, because of that palladium will give, okay, palladiatoda 5s orbital will give 2 electron to 4D. Okay, 2 electron to 4D and it will form 5s 0 4D10. Okay, so when you consider 5D series, okay, this is 4D series, 5D series. So 5D series we will represent with xenon, but 10. Yes, it will form 10. Yes, so here you can see 5D series we will represent with xenon. So lanthanum to, yes, so lutetium. Okay, and yeah, no, lanthanum lutetium is that, okay. So that is F-lock elements. So lanthanum, hafnium, okay. Yeah, so here you can see the exception is for all expensive metals, okay, that is platinum and gold is here, okay. So same here, only one electron will give, okay, 6s will give one electron to 5d, okay, 6s will give one electron to 5d, then it will form 6s1 and 5d9, and here also you can see 6s1 and 5d10, okay. Palladium and gold, okay, not palladium, platinum and gold. Palladium is exception of exception, okay. I hope it's clear. Then we are moving to 6 series, okay, 60 series, okay. So 60 series la you can see here exception irukkiradhu most important ana Rg da, okay, 6th series la, okay. Here you can see Rn and 7s, okay, it's wrong, Rn 7s1 6d10. This is the electronic configuration, okay. Now this is the electronic configuration. So red and which da nama normally என்ன 6d represent பண்ணும். Only one exception is there, Rg la, okay. So guys, exception மட்டும் தான் இங்க, okay. இதுல இருக்கிறது இந்த highlight பண்ணி இருக்கிறது எல்லாமே exception தான், okay. Zinc, cadmium, mercury and copernicium is one exception. So other we are not consider, okay, we are not considering 12th group element as transition metals, okay, transition elements or transition metal. Why? Because it's contain 10 electron in their d orbitals, okay, in their d orbitals. And here you can see the other exceptions, okay. So and here palladium, okay, palladium is exception of exception. This is very important. So idila important aanadhu one is palladium, another one is copernicium. Here you can see when you consider group 11 la ellame enna irukku oru exception irukku, okay, ellame exception la dhaan irukku ella elementum. And when you consider group 2 la 2 elements, okay, 2 elements. And here you can see 4d series la, okay, 4d series la like 2 elements kapram baki ellame it will show exceptions, okay, baki ella elements will show exceptions. And one more point, so here உங்களுக்கு இந்த note கடச்சதுக்கு அப்புறம் you can see the star பண்ணி இருக்கிறதோட meaning, okay. One electron move from ns to n minus d orbital and 2 star, actually palladium 2 star irukku. So the meaning of 2 star is 2 electron moves from ns to n minus 1d orbital, okay. So here we can say maybe they will ask, okay, maybe they will ask, so off-bow principle, okay, it is actually violating off-bow principle, okay. All these elements are highlighted elements are violating off-bow principle, okay, off-bow principle, it's violating off-bow principle, okay. I hope it's clear, it is violating. Maybe they will ask this type of question, which element is violating off-bow principle, okay. Here you can see. Next is physical property. So when you consider physical property of d block elements, normally first one is physical property consider பண்ணும்போது we will consider melting point, okay. So when you consider melting point, so we know that it is normally higher than S block metals, okay. When you consider S block metal melting point and D block metal melting point, the melting point is more in D block elements, okay. The melting point is more in D block elements. So here you can see scandium, chromium and manganese, okay. So here you can see a dip in melting point, okay. For manganese you can see a dip. Why? Because of due to crystalline structure of manganese, okay. Due to the crystalline structure of manganese, the melting point is less, okay. You can see the dip because of the structure, or we can say weak melting point. Why? Because of weak metallic bonding, okay. It is because of weak metallic bonding you can see the crystalline structure, okay, because the metallic bonding is actually weak in manganese than chromium and scandium. So you can see a dip in melting point, okay. Here you can see for manganese tellurium, okay, it's only for manganese and tellurium. Next, we know that melting point is directly proportional to enthalpy of atomization, okay. Melting point is directly proportional to enthalpy of atomization. This is also very important. So when you consider enthalpy of atomization, means we can say that like it's the weak, because of that weak metallic bonding, okay. You can see enthalpy of atomization is less in manganese, okay. Enthalpy of atomization is less in manganese because of weak metallic bonding, okay, because of weak metallic bonding. So when you consider, yes, 3D, 4D and 5D series, so we know that for 3D series melting point is actually less, after that 4D series, then 5D series, okay. Here also you can see the same thing. So 5D series melting point is more than 4D than 3D. So down the group enthalpy of atomization increases. You can see down the group enthalpy of atomization increases, metal bonding increases, melting point increases. So down the group what will happen? Enthalpy of atomization increases. If enthalpy of atomization increases means metallic bond will also, the strength of metallic bond will also increases. So melting point will also increases. I hope it's clear, Manju. I hope it's clear. Then we are moving to atomic size. So when you consider this is 3D, this is 4D and 5D series, okay. So when you consider 3D, 4D and 5D series, here you can see this is our 3D series, scandium, titanium, vanadium, chromium, manganese, okay, iron. So when you consider 3D, 4D and 5D series, so the atomic radius obviously it is increasing, okay, obviously it is increasing. So we know that from left to right atomic size will decrease, okay. From left to right atomic sizes decreases. Down the group, okay, for down the group the atomic size increases, okay. So yes, you guys are, yes, regular students of Re-NEET Tamil Nadu's channel. Yeah, your name is Ashika. Hey, now Manju இப்பதான் சொல்றது. இது வரைக்கும் நான் மஞ்சுவை lots of time பார்த்திருக்கேன், பட் ஆனாலும் எனக்கு தெரியாது மஞ்சுவோட பேரு name actually Ashikaன்னு. Okay, hi Ashika. I thought your name is Manju only. So Ashika வராது இதுக்கப்புறம். Okay, so yes, so here you can see atomic radius. Obviously down the group atomic radius will increases, okay. Atomic radius will increases down the group. When you consider left to right atomic size will decreases, okay. But here you can see when you consider iron, cobalt and nickel, so the atomic size is almost similar. So first it's decreasing. When you consider iron, cobalt and nickel, the atomic size is almost similar, okay, for iron, cobalt and nickel. And after that again the atomic size is increasing, okay. After that again the atomic size is increasing. Scandium, titanium, vanadium, chromium, manganese. After iron, cobalt and nickel, the atomic size is almost similar. Then the size is increasing for copper and zinc, okay. It is increasing for copper and zinc. This is the atomic size of 3D series, okay. It is the atomic size of 3D series. So when you consider metallic radius, okay, when you consider this is atomic radius and ionic radius, okay. When you consider metallic radius, so metallic radius for chromium and manganese, when you consider chromium and manganese, so for manganese the, just a second, yeah. Okay, I think I can finish within 10 minutes. Okay, then I will give break. Or should I finish now? I will give PPT for them. thing is like, okay, it works, yeah. So guys, I will give you a 15 minutes break. So okay. So okay, so I will come within 15 minutes. Okay, da?